This conference will now be recorded.
Great. Good afternoon and welcome. This is the meeting of the West Basin Municipal Water District Engineering and Operations Committee and the special board meeting of the Board of Directors. We have a quorum. So any public comments?
I've not received any requests for public comments.
Okay, is there anybody out there in the audience that would like to speak? Hearing none. Any presentations?
We have none, Chairman Alvarez.
Okay, so then let's go ahead to the action calendar. It looks like we have 4 items. So General Manager, do you want to go ahead and make those presentations and go through those items?
Yes, thanks again, Chairman Alvarez, members of the committee, and members of our board and guests and staff. We do have 4 items as you on this today's action calendar, and the first one we lead off with is what we call a time extension only request. This is for a project that was awarded right at the beginning or precipice of the pandemic. To perform an audit of our aging computer control system for a recycled water program. And it experienced some delays along the way due to the pandemic. And although we have plenty of budget, enough budget to finish the project, we need to have a time extension to allow it to be completed. So I think we have, let's see, we have our Manager of Engineering, Wendell Johnson. Wendell, where are you? There you go.
Good afternoon.
Good
afternoon, Patrick. Thank you for that. Good afternoon, Chairman Alvarez, President Williams, and members of the board. I'm here this afternoon to request a time extension for the DCS audit contract. I'm going to give a little bit of an update of the project, and then we'll move from there. And I want to assure that the public understands what I'm talking about. So I'm going to define some of the moving elements that we have here. First of all, the DCS project affects our main plant, the Edward C. Little Water Recycling Facility, as well as the 3 satellite facilities at Chevron, Carson, and in Torrance. What is DCS? DCS is the automated controls that runs almost every aspect of the recycled water process. Okay, and what we've done is this is a multi-process project, and it's a multi-year project. And we're in the phase we're about 65% complete of what I'm calling phase 1, which is the DCS audit. And it's essentially a step-by-step review of all the equipment and all the connections that we have out in the field. And just to let you know, some of the findings, we have almost 9,000 different connections that tie into the computer network. The duration of the project is expected to take about 3 years to complete. In this audit phase, we have 3 major tasks that are being conducted. The first task is the planning and review phase. The second is which is complete. The second is the actual physical audit, which is task 2, and that's conducting the audit and reviewing the findings, and that task has been completed. The next is the development of technical memos to develop a direction or a roadmap for the agency to go in the direction of upgrading their DCS system. As part of the audit findings, we determined that about 62% of the equipment is near the end of its service life, okay, which represents impacts the organization, and it represents a problem for getting spare parts and keeping the system up and operating, as well as the technology for this has some of the components are as old as 25 years. In general, the useful life of a control system is about 10 years. It's something that moves quite fast with the technology, and so we have bottlenecks within the system which makes it very difficult to get data across. Okay, and essentially the project was delayed a little bit because of the pandemic, establishing a protocol for visiting the site, as well as getting people together just to review the site. Also, an administrative error on my part allowed the contract to expire. I entered data as I was watching, and I've changed the protocols for that before we could give it an extension. And so the action I'm asking here from the board is to staff recommends, I will read that now. Staff recommends that the board authorize the general manager to extend the terms of agreement W2903 with Corello Engineering through August 31st, 2020 for professional engineering services to complete the audit of the distribution and process control system audit and the development of system architectural diagrams. And if there's any questions, I'm here to address them. Thank you.
Thank you very much, Wendell. Any questions from the committee members?
None from me, thank you.
Okay, anything from the board members?
No questions, thank you.
Okay, real quick, this is just a time extension, basically through the end of August.
Correct, Chairman. We have sufficient budget to complete the audit.
Okay, that's great. Then if there's no objections, we'll move this for recommendation to the board to approve the time extension.
I concur.
Okay, thank you. Next item up, General Manager.
Okay, Chairman Alvarez, our second item on the action calendar today pertains to our Palos Verdes recycled water pipeline project, which reached a kind of major milestone recently where the location of a key component of that project, the booster pump station that would bring recycled water up to some of the customers in Torrance and all the way up to the PV golf course, where that particular siting of the booster pump station was agreed upon and approved by the City of Torrance City Council to allow us to move forward with the project. So we have an item here before you that includes its final resting place. Its final location, after looking at maybe as much as 19 sites, is near Lago Seco Park over in the corner of that park by the Little League grounds there. Anyway, there are some utilities and some things that are in that site that have to be addressed. And so there's some redesign work and some other work associated with the project that we need some additional funds to cover that design work, redesign, and other work associated with the project so we can finalize it and move ahead. We have our excellent supervising engineer, Veronica Govea, who's been with this project from day one. And Veronica, would you please handle this matter for the board and public and everybody here? Thank you.
Thank you, Patrick. Good afternoon, Chairman Alvarez and members of the committee. I'm happy to present this new project. Well, it's not a new project, but better news, from the past in regards to now we have a approved pump station site. So you can please follow me to agenda number 5B on page 6 of your packet to discuss the agreement for design engineering services of the Palos Verdes recycled water pipeline project. So West Basin and Gunn & Fleming entered into an agreement W2826 for the design of the Palos Verdes recycled water pipeline project. And this is a project that consists of approximately 3.6 miles of new recycled water pipeline and will also include a 500-gallon per minute pump station. This project will deliver approximately 240 acre-feet a year of recycled water to 7 sites within the cities of Torrance and Palos Verdes estates. And this water will be utilized for irrigation purposes and will be serving parks, schools, medians, and a golf club. On your packet, under page number 10, we included a map of the region. So the alignment as well as the project sites that will be targeted can be located on that particular attachment A. To briefly summarize the project, over the last couple of years, staff has been able to complete several items, which includes the feasibility study, the CEQA documentation, the preliminary design report. We have also coordinate staff meetings with the city representatives, Palos Verdes and Torrance. We have also performed outreach. We have advanced the design of the pipeline. We have also addressed comments that have been received from public and from city officials. We have worked with some of the permitting jurisdictional entities to advance all those permits that will be needed for the project. We have also prepared renderings, layouts, analyzed several pump station sites, as Patrick mentioned earlier today. And again, we have also made several presentations to city officials, chambers of commerce, associations, and we have been able to obtain some of the project support letters from some of these entities, which you can also find in your attachments in the packet. As Patrick mentioned, we recently got the approval from the City of Torrance City Council in regards to the proposed pump station. It is important to mention that the proposed pump station site that was approved is a new site that is 400 feet east from the original location, which was the preferred location that West Basin had originally looked forward to install this pump station. The new location is still within the same park area, and however, like this new location was generated from some feedback that we got as we were progressing on this project from the public and from cities. For references on the locations of the pump stations, there's a couple of attachments that have been addressed to your packet. Under attachment B, which is on page 11, you can see the map that shows the regional locations that we have looked into. And essentially that particular area shows the site as being basically an empty lot that it was like with dirt ground cover, and it was ideal. It was away from the park, and it was going to be like towards the back of that site. So it was kind of like a hidden area. And unfortunately, there was feedback that was received, and coordinating with public, coordinating with city officials, looking into what we can do, working with our designers, we were able to come out with analysis of their locations. And ultimately, this resulted in a new location that, again, is within the same vicinity, just like a few feet away from the original location. And this new location, you can locate it under your attachment D on page 20. And one of the things that that you guys will be able to look into this particular exhibit is that the ground cover obviously is different. On this one, there is a parking lot that we will need to make some site adjustments, and there's also some utilities that are in the area that we're going to have to basically work on in order to install the pump station in this location. So in order to complete the design, we will need the additional engineering consulting services to complete this permitting and design work. We need to perform additional geotechnical investigations, since this is a site that was outside from the original location, as well as doing some geodetic or survey, basically analysis or report testings and survey. Design the pipeline extension from the original location to this new location, and modify the existing site and the utilities in the area. With this, I will read the recommendation. The recommendation is that the board authorize the general manager to amend agreement W2826 with Gunnar Fleming for additional engineering and services for the Palos Verdes Recycled Water Pipeline project in the amount of $194,617 plus a 15% contingency of $29,193 for a total increase of $223,810 and a new total not to exceed agreement amount of $1,214,374 $4.70. Thank you for your attention, and I'll be happy to answer any questions that you may have.
Okay, well, thank you very much for the report. Any committee member comments or questions?
Yes, Mr. Alvarez, if I could. I'm very excited to hear about this. I mean, it was like March 2016 when I first got really excited about this project, and then things kind of went, yeah. Now, one of the things that we're really concerned about is the public support for the project going up the hill. I know that we had talked about early on that there were some people in Torrance had some concerns about wanting to do a water line for the people on the hill. So I hope we were able to work out that through the city council there in Torrance to help us smooth that road, and that we won't have that problem when they go up the hill. Now, the budget or the support for the project, the funding source, where are we on that now? I remember it was like the whole project was going to cost like 7.3 million, and the support funding was split up between us, the city, and the golf course. So I was just wondering, what is that like now?
Yes, and Barker.
Yeah, I can take that. I can take that, Veronica. So we do have some funding. A little bit of this discussion is in the fiscal impact. You can see that a little over $2 million has been secured from a Proposition 84 funding for the project, and we've recently extended the duration for that, and it's good for the duration, the new schedule of the project. That's a little bit over $2 million. And then Cal Water will be committing $2.5 million towards the project. The golf course themselves are going to be committing a total of $1.1 million. 600 of that would be for improvements on site on their property. And then they're also committing $500,000 for some of the improvements off-site for this project. And so it's worth mentioning also that we had applied for low interest funding with the state board, SRF funding, and they've contacted us recently and told us that we went up the list. So we are right now getting ready to submit a new package to get SRF funding, low interest funding for our portion of the costs.
So are you saying right now, do we have enough money secured to finish the project as the estimate stands today?
This project, the funding for this project has been included in our capital budgeting over the years, and has been one of the this project has been one of the strategic goals for West Basin to increase recycled water supply to the tune of 240 acre-feet per year. So it's one of those projects that was determined to be the one that will give us more bang for our buck. So yes, it has been part of our capital budgeting process for a while now.
But do we have the money now? Do we have it in the bank?
Yes.
Okay.
Yes.
Well, I'd add to that, Director Williams, we say we have $5.6 million, sort of more or less grant money from Prop 84, Cal Water, PV golf course contributions, low interest loans, and then it would be the typical financing instruments to make up the difference. whether it's it can be PAYGO or other monies that we have to pay the balance.
So how much is the balance then?
Well, the balance, Barker, what is the current estimated cost of the project? I want to say 12.9 million.
Right, it's 12.9 million. So a little over 5 million of that would be the other funding sources. So about 7.4 million would be West Basin's balance.
And where would that come from?
Well, like I said, I think the original plan, before this SR funding thing came into play, the original plan, I think, is through commercial paper.
Okay, that's it for now. Thank you.
Okay, any other questions from board members?
No, I have no questions at this time, Chair Alvarez.
Okay, I've got a couple of questions. So first on the action that you're requesting before us, all we're doing right now is approving or recommending for approval an additional $194,000 plus for the design contract.
Yes, plus contingency.
Plus contingencies, okay. Now, this is the 5th amendment to this contract.
Correct.
So we started out with a contract at $560,000 and we're up to $1.2 million in design fees.
Yes, for out of scope items that were not included in the original design scope.
That still seems pretty hefty increase in a design contract. You go from basically over twice the original amount. But all we're doing today is approving the additional amount to complete the design. With this approval, there will be no request for any additional design funding.
We don't anticipate that at this time.
Barkev, too, maybe you can share with the committee the 3.6 miles of pipeline. How far along percent-wise is that design?
It's close to 90% complete. 90% draft on the pipelines.
So to answer Chairman Alvarez's question, then, so this should cover design of the pump station, and we are almost done with the pipeline.
Right.
That would be.
I would hope so. I mean, you started out at $560,000, so it's not a bad little contract for a design firm.
Yes, and I think, if I may, Chairman Alvarez, I think, Mark, you just alluded to it, the original contract has for some reason, left out a chunk of scope. Can you just identify what that was? What was not included as part of it? Veronica, do you want to answer that?
Yes, I can answer that. And on table A of your board package, you can see a summary of all the agreement, the original agreement as well as the amendment.
Maybe you might want to put it up on the screen. There you go.
Okay, yes. So yes, the original agreement started at $560,427. Amendment 1 was just a time extension. Amendment 2 is basically an amendment that was done as part of the contingency. However, on Amendment 3, we did go to the board on June 22nd of 2020 and added some additional budget. And this additional budget was essentially to cover the construction engineering services. So essentially, when this project went out for bid for the design support, we were still working with the cities and getting all these other agreements. So we were like trying to determine in regards to the construction, if it was going to be a separate, phase to be added later on. And essentially, as the project progressed and we obtained approvals from grants and agreements, essentially the additional scope of work to review chap drawing submittals, request for information was added into the scope of work. So we went to the board to request that additional budget. And the other amendments that have been done, again, they're being done. There's a lot of changes that we have worked with the city of Torrance in regards to pump station configuration. Basically, that was added, basically a scope of work that had not been anticipated. And on Amendment 3, there was discussions on the regional side to modify basically the empty lot, which was for a parking lot. So that's why there was that need to go to the board back last year.
So bottom line, Chairman Alvarez, there was some things that weren't included in the original scope of work that were added, and there were other things that were added that you mentioned. The parking lot, I think that was the 27 parking spaces that the city originally wanted as part of this, but then the location got changed to a different location, and that's kind of a cost savings in terms of putting them in. I think it was $100,000 to add those. Those went away when we went to this new location. So it's been a protracted schedule. The issue over the siting of it, the siting of the booster pump station took up a lot of time and effort and delay, I would say, of about 18 months, but had a happy ending, but didn't help the bottom line. But I would agree with you, 500,000 to 1.2 million is a big jump when you look at it percentage-wise. But again, some stuff was left out of the scope to begin with, and then the protracted, drawn-out schedule to get us to this point didn't help. But we're here.
Okay, so, but basically all of the work that has been done and will need to be done to complete the plans and specifications is basically all engineering. This is all PS&E work that we've been paying for.
PS&E and then engineering support during construction, yeah.
Oh, okay, so let's clarify that for me. When you say engineering support during construction, what are we talking about?
Shop drawing reviews, response to RFIs. Veronica, can you expand on that?
Okay.
Yeah, clarifications that happen when you are doing construction, any last minute change. There's always, having cities installing utilities long time ago, there's always a potential to run into unforeseen facilities that either have been abandoned or that record drawings were never provided to the district. And therefore we need to react to create a new design and redirect the contractor so they can basically proceed accordingly with the construction, as well as every now and then there's a chance for a change order that though the construction manager will be looking into reviewing, there's still sometimes a design component that also needs to be analyzed. So those are basically the construction services that the designer will be participating on.
Okay, so they will be providing full construction support for the engineering side to resolve any RFIs that come in, any change orders that need to be issued because of problems with the plans and specifications. And it's all inclusive, no more money, request for money. Does that include as part of their construction services, preparing the final as-built drawings once we get the as-built from the construction manager and the contractor?
Preparation of record drawings are included on the project.
Yes, I just want to clarify, Director Alvarez. Yes, this service is called engineering support during construction. Just don't want to confuse it with construction management services, which also includes inspection. That is separate. That will be coming once we get the project out to bid. We'll go for CM services separately.
Thank you for the clarification. It does include, though, that they're going to do the final as-built drawings.
Yes.
Correct.
Okay, going back to the budget. On this portion, the full $1.2 million that we're, if this approval goes through, money for that is currently available. This is not money that is going to be put into CIP that's subject to the approval of the budget. We're talking about money that is currently available.
The project itself was part of this capital budget approval for this year. We anticipated being in construction right now as we speak, but because of the delays we haven't. So there was, I think it was north of $9 million approved for the capital budget for this project for this fiscal year that we won't be spending in this fiscal year, but it would instead go into the next fiscal year when construction starts.
My question is very simple. The money is currently budgeted for this project when we have the money.
Yes.
Okay. Next question is, you mentioned that the overall total cost of the project is $12.9 million. Is that inclusive of this, or is that just the construction costs?
It includes it.
So design, construction, and construction management is going to be about $12.9 million.
It also includes all the past costs and feasibility study, PDR, that kind of stuff.
Okay. And if I go to some of the comments that the general manager made earlier, we have right now about $5.6 million that it's either been obtained through grants that have been already approved and or commitments from some of the users. Is that about right?
Correct. Sorry, I didn't have I was on mute. So yeah, we have a property for, which I think we went through that, was property 4 was $2 million. Cal Water is processing there, which is a different route, but through the PUC, $2.5 million, $500,000 in cash from PV Golf Course for contribution, and then an offsite contribution, maybe the other way around, of $600,000 for a total of, I think, $5.6 million, other than our contribution to the project. Is that correct, Margaret? Or Margaret's on the phone too. She wants to chime in.
All right, so we have 5.6 million of a total of 12.9 million. So if we move forward with this project, it's possible that we can go out and seek some additional, not loans, but outright grants for the difference of the 5.6 to the 12.9 million.
That's correct.
We can move forward on trying to achieve, and since we got some time, this has got enough finished design, et cetera, before it goes out to bid and before it's awarded.
Correct. And we're actually doing that. We're coordinating, EJ is coordinating, and the project is being presented for different funding opportunities. And we will continue on to doing so as we would complete the design with this approval. I just wanted to clarify, it's really, it's not 5.6, the $600,000 is for the on-site stuff. So it's $5.045 million.
Okay.
But the $600,000 we don't have to spend. That's coming from PV, right?
That's PV on their on-site improvements.
Okay. Any other questions?
Yeah, excuse me, Mr. Chair. The total estimate of the project, considering design, engineering, and construction, the total amount, what is the estimated cost of the total project?
$12.9 million, including all the work that we've done so far.
Okay, thank you. Oh, but wait a minute, one last thing. So that is not a budgeted number, because we don't budget the entire project, but for this year, so the budget, for the current budget, how much is in there for the project?
I think for the current budget, we had $9.7 million, if I'm not mistaken.
How much?
9.7.
Okay.
That was with anticipation of a different schedule that we would be in construction potentially, but pandemic and what we had to do to meet the issues brought up by the community and stuff raised by the city, and that extended process pushed everything back. But yeah, we got 9.7 in there.
Okay, so it has to be made clear to the public that the changes or costs incurred during the design phase were not caused by the designer. It was other things that came forward that cost to go up during design.
Correct.
Thank you.
Okay, so with the understanding that at least there is $5.045 million that we have in cash for the project right now, and that moving forward with this, it would put us in a position to obtain the rest of the financing for the construction of the project through grants and or other arrangements. Is the committee supportive of moving it forward to the board for approval?
I would recommend that.
Okay, so that's what we'll do. We'll recommend that this move forward to the board. All right, next item up.
Next item up, Chairman Alvarez, is item 5C. And this item is related to technical support services agreement that we've had in place for, I think, the inception of the entire recycled water program. And principally, this relates to support for the low and high pressure membrane technology, operationally and otherwise, low pressure being microfiltration, high pressure being reverse osmosis. And the last time it was bid out about 18 months ago, or a little less than 2 years ago, SPI with the sub, with Hazen Sawyer subbing to them for the complete package, were awarded the bid for, I think it was $600,000 for 2 years. And some of the work, again, was impacted during the pandemic. Some of it wasn't done. Some was not done, but not completed. And staff here will be asking for an extension of this existing contract with some additional money, not a whole, for 1 year, for continuity. And I understand that we have Susanna Lee here who can speak to the performance of these guys who have been working for us and what we're asking for. Susanna, who's our engineer, operations engineer, I should say. Sorry, Susanna.
Susanna, go ahead.
Okay, thank you, Patrick, and good afternoon, Chairman Alvarez and members of the board. So as Patrick mentioned, that this item that I'm about to present is in talking about the important role that it has played in the West Basin successful recycling water program operation. So let me start off by providing some background and context. As you're all aware that the West Basin is the only agency in the world that treats and produces multiple types of recycled water that meets various water quality specifications. And of the various treatment processes that are employed at our plants, membrane technology is the heart of West Basin advanced treatment processes, and which makes up roughly 40% of our treatment capacities. And at any given time, West Basin has to operate and maintain with over $10 million worth of membranes at all our facilities. And this includes microfiltration and reverse osmosis membranes. And to best protect the substantial investment West Basin has made in the membrane technology at our facilities, West Basin has always retained services of third-party industry membrane expert to provide the independent condition performance and evaluation of our membranes. And staff would like to point out at this point that even though that many utilities that do utilize membranes at their facilities, West Basin is unique in several aspects, where it is one of the few agencies with contract operators, and unlike most agencies that only have to focus on one type of product, water quality. In addition, West Basin's recycled water treatment operation is met with very challenging and constant changing source water quality. And furthermore, our facility is very complex due to the interconnected processes to produce the different types of product water. And these factors with our staffing level sets our operations apart. And so West Basin has found great success in the last 20 plus years with retaining third-party services that provide this dedicated and expert attentions to ensure our membranes operating at optimally, and has in the past provided quick responses that staff needs to help ensure all permits and customer specifications are met. Finally, West Basin is not the only agency that utilize third-party help to monitor and provide technical services on the membranes operations. And this includes, but not limited to, Orange County Water District, Kuiper Valley Water District, and Mesa Water District. Continue on, like in 2013, West Basin has expanded this technical support service contract scope to include specialized supports such as troubleshootings and providing recommendations to corrective actions for other processes, including Title 22, solids handling, nitrifications, and hundreds plus miles of distribution pipeline. And as outlined in the memo, the scope of the technical support service can be categorized or can be separated into two main categories: membrane focus, which include monitoring and optimization, and the other task-oriented focus on the other treatment processes. For the membrane monitoring and optimization tasks, they include a third-party audit and on the condition assessment of the membrane, and that is to ensure that we maintain compliance as well as customer meeting the customer specification, and as well as developing trends and analyzing water quality and troubleshooting any deviations from expected performance. And all these are really critical to a successful membrane operations and has to be done in a regular basis. And besides these monitoring tasks, consultants in the past has also provided their industry knowledge on membrane applications, development of membrane specs, and provided valuable inputs in helping West Basin to develop the groundwater recharge regulation compliance requirements. On the other tasks, those include providing guidance on treatment processes, improvements and procedures, and evaluating new and alternative treatment systems on optimizing the current existing treatment facilities. So all these tasks, you can refer to table 1 on page 27 of your packet for some of the major tasks that have been done in the previous contracts. Coming back to the purpose of this memo, the current contract, as Patrick mentioned, has a value of $600,000, is set to expire on June 30th of this year. As mentioned, SPI and Hazen Sawyer are the consulting firms on this contract. The scope of services is set up to allocate approximately half the budget for membrane-focused tasks, which are headed up by SPI, while the other half is budgeted for technical assistance and as-needed tasks for other processes, which are mainly performed by Hazen Sawyer. The ongoing membrane-focused tasks have been carried out as budgeted. However, due to the COVID restrictions, much of the as-needed tasks for the other treatment processes has been delayed this past year. And we're just resuming back to doing those projects or tasks. So table 2 lists on page 27 as well, lists the tasks that are ongoing and scheduled to be completed later this year. There's approximately $89,000 of the remaining budgets for Basin that are planned and will be utilized later in fiscal year 2021 and 22. So as Basin continues to complete these tasks, staff is coming to the board requesting and recommending to provide additional funding to the SBI portion of the technical support services scope. As this provides continuations and for the membrane monitoring and optimization task. Staff is also requesting 1-year extensions, which also will allow the other technical and as needed tasks to be completed. So please see attachment B for a copy of the proposal. Before I read the recommendation, and as pioneer and champion for development of the recycling water program, West Basin producing multiple types of advanced treated water and variable source water. This success really attributed to the strong West Basin leadership and dedication from our operator, but also really with our partnership with industry experts in membrane technology and other technology. So this relationship has served as a conduit to allow West Basin staff to have industry insights, not only to the membrane technology, but more importantly, to provide that information from the recycling, water compliance, and regulators, because many of these consultants are service expert panels on R&D studies and regulatory committees. So with that, I would like to read the recommendation, and that is that the board authorized the general manager to amend agreement W2876 with Separation Processes, Inc. for operational technical support services and increase the support services budget by $150,000 for a new total not to exceed amount of $750,000 and extend the agreement by 1 year through June 30th, 2022. With that, I'd be happy to answer any question.
Okay, well, thank you very much for that report. From the committee members, do we have questions?
I have a question. This process, has it been helpful in getting us the awards that we receive concerning our recycled water system?
In helping, I'm sorry, can you repeat? In helping us to get what?
Because of the quality of water that we produce, the customer relationships that we have. If we were doing a different kind of membrane, whatever, that we would or would not be able to get these awards, perform at such a high level that we get these awards?
Yeah, I could maybe take a shot at that, Susanna. A good question. Yeah, one of the very distinguishing characteristics of the success of our Great Recycled Water Program is West Basin's been a pioneer with membrane technology. We started out with lime clarifiers back in the mid-90s, and then we're the first in the US to go to microfiltration instead of using lime clarifiers as a pre-treatment for RO. And then we also have pioneered, and you'll see when you go over and visit the plant, there's an R&O pad right outside the control room, and all kinds of new and first generation high pressure membranes have been tested there. And so we've been seen as a leader, and that's been well advertised and published. And yeah, it contributes to our high standing in the community. You'll remember last year, recently, we got the leadership, the utility leadership in recycled water award from AWWA and water reuse. So yeah, this is part of the package, I would say, Director Williams, and the distinguishing thing, the distinguishing signature technology that we use and as innovators. And SPI in this case, have been along that path with us from day one. So yes to your question.
Okay, thank you.
Do you have any other questions, Director Williams?
No, that's it.
Any other questions from the other board members?
No questions. Thank you.
No, thank you.
Okay, I've got a couple of questions. Susanna, so when did, were, the request here is to extend the contract for another year, and that will include funding for another year, 150,000. When was this contract originally awarded?
When was it first awarded? It was 2019.
Okay.
So it was original term was 2 years. So we're coming up to the 2 years term. And because we see that their tasks that were delayed and a lot of them are just starting and resume this year, so we'll need extension on those tasks to provide the continuations of the services on the membrane. So we need to add fundings for that portion of the work.
Okay, so the recommendation then is the extension and the additional cost for funding that extension. Do you anticipate using all of that? Because a lot of their services are kind of as needed support services.
Yes, so a large portion of it is providing that continuous membrane monitoring work. That's we, based on previous contracts and previous years, we know that funding will be spent. There are also a couple of projects that we will be requiring SBI's involvement. There are 2 pilot studies that will be coming up in this fiscal year, including anti-scaling pilot study, as well as helping us to develop a pilot study for testing phase 4 replacement membranes that will be coming up for replacement starting next year, early next year. Right now, that phase 4 membrane, phase 4 MF membrane, we're using Sinor membranes. So that's the only one that we tested last time and approved to use. So if we do not want to go back to sole source to Sinor, there is now a new PVDF membrane that we want to test to make sure that it works with our water quality at our plant. So we're planning to test that membrane. So we see that we'll need a substantial assistance from SBI. In addition, in the fiscal year to the 21 and 22, we also need to procure some RO membranes for barrier, as well as the JMM as well. So we'll need their assistance in helping us to review and revise the RO membrane specification. So all those, we anticipate that $150,000 will be utilizing that budget for these items, in addition to the membrane monitoring aspect.
Okay. And then after this coming 1 year extension, we'll put this out to RFP.
Correct.
And I'm sure SPI will do a very good job again. They're very knowledgeable about all of this. So regarding the budget so the money that will fund this is currently budgeted. In other words, what's the budget impact?
So the budget for this, the work that has been done and continue to do until the 2 years are up, is part of the operations budget, and it was allocated so in the 2021 budget. And so with this extension moving forward into next year, we included in the budget presentations that we're giving to the board, we accounted for or assumed that this would continue on and would be in the budget moving forward in the next fiscal year.
Okay, so this is not currently budgeted, and the approval of this particular contract amendment will encumber the board, but the money would then have to be appropriated in the 21-22 fiscal budget.
Because the extension would go on for a year into the next fiscal year.
Okay. I'm not comfortable with awarding and approving contracts that we don't have the money budgeted for. I understand the need for this work. I would recommend that we look at just taking the money out of our reserves, and that when we approve an extension to a contract, that we also encumber that funding for that contract, and not approve an extension without encumbering funds, and then commit the board to having to approve a future budget, which the board may or may not approve. Is that a possibility?
Margaret, I'd just like you to opine on that. I mean, a couple of clarifications. Obviously, we're funded, Chairman Alvarez, through June 30th of this year. And not all of those funds are going to be expended because of the pandemic work that wasn't done. But traditionally, we've always put items in the budget that to cover costs going into the future. Any budget, you're looking for any cost that we could incur throughout the 12 months starting July 1 of 2021 through that full fiscal year. But I'll let Margaret, Chairman Alvarez has a different approach. Maybe do you want to opine on that, Margaret?
Yes. So I will just say, I mean, just a good example of it is one of the things you're talking about here is the distribution O&M contract that is a 3-year contract. So, you know, we only do a 1-year budget. And so you're asking us to do encumbrances. I know that is something often done by cities as a enterprise fund. We are not required to do encumbrance accounting, but I can certainly look into it and see how to approach it in the way that you're saying it, because what you're describing is saying that if we're only approving a 1-year budget, we're only going to be doing 1-year contracts. And that may be difficult to do when we're trying to do multi-year contracts.
I'm not asking that we do 1-year budgets. I'm asking that when we award a contract, we encumber sufficient funds to cover that, and those funds would be spent over multiple years, and those funds are encumbered and they can be carried over year to year, so that the money is available at the time that the contract is awarded. Most contracts are not, at least a lot of the contracts that we would do for construction and other services tend to be more than 1-year terms. So
right. Yeah, I hear what you're saying.
Go ahead.
I was just going to say, I hear what you're saying, and we do have a designated funds policy that it does, you know, allow us to have some consideration for sort of future funding, and maybe in that contemplation of we are looking at that policy currently and take a look at how to approach this encumbrance here. That is not something historically that the district has done as it relates to it. What we have said is that, you know, in a multi-year contract, we would say that it's funded in the current year and it would be in future years' budgets, so that the board is on notice, if you will, that this is, you know, subject, you know, to future budgets, if you will.
Yeah.
But we have reserves that are sufficient to cover $150,000.
Yeah, we do. Yes, we do. Yes, we do.
So when this comes back, you could bring this back with an appropriation of the reserve, so that all of the money that's required would be in place at the time that we extend the contract and award any cost increase.
Yeah. All right. I will work with our auditors and to make sure that we've got that all accounted appropriately and to address your concerns.
Yeah. Mr. Chair.
Yes, sir.
I'm familiar with that process because the cities that I work for, that projects, multi-million dollar projects were not, I mean, the funds were encumbered at the time, and some cities used a purchase order process to encumber the funds so that when it did come time to do the project, they had the money to do the project. They had the money to pay the contractors. I was involved with a city that would commit to a multi-year project, but didn't encumber the funds. So when it came time to pay the contractor, there was no money around. So that made the city look pretty bad. So I understand that where you're coming from, that needs to be taken care of. But as Margaret was saying, that for some water boards fund a little differently. But it makes me nervous too to think that we have committed to do a project, but we have not encumbered the funds. Thank you.
Hi, Mr. Chair, this is Director Gray. I have a question, please.
Go ahead, Director
Thank you.
Gray.
General Manager, when items like this come on the agenda, do you provide a funding source already when you ask us to approve an item? What do we traditionally do?
Depends on the item. There's something like this where we're asking for an extension of 1 year. And like Margaret alluded to, there was a special district. Yeah, of course we have funds that would cover $150,000, but we've included in the budget for the upcoming year and or multiple years if it straddles multiple years. That's the normal process. This would be, if I understand Chairman Alvarez correctly, would be to take money from the designated funds, which Margaret will look into, and appropriate that or have it encumbered ahead of time, which would be different than what we traditionally do to cover this extension of $150,000. Now,
no, I was asking you, what do you traditionally do? I wasn't talking about what Kirk Alvarez was proposing. I'm saying when you have an item on the agenda, don't you already have an idea if the board approves it, where the funds would come from? So that's the question.
Yes, well, if I could direct you to the fiscal impact back at page 29 on this. We have this on every single item we bring to the board. And the fiscal impact in this particular one, and this is typical, funds will be included in the fiscal year 21-22 operations budget.
Okay.
That's what we look at it. Looking forward, we're including that in the budget, which the board has to approve.
Okay, thank you.
Okay, any other comments? I would say that we can move this forward with the understanding that Margaret's going to look to finding the $150,000 and that will be included in the recommendation of the full board. Is that okay with you, President Williams?
Yeah, I thought the funding we know where the funding's coming from, don't we?
Yep, it's going to be included in next year's budget, but Director Alvarez is saying for this, he wants to deviate from that normal process and have the recommendation include money taken out of designated funds and say we've already, that's what Margaret has to look into, assign that $150,000 to cover next year. So it wouldn't be in the budget, kind of, sort of, but it would be part of the recommendation. So we have to look into that.
Yeah, well, I think that should be done during the budget process. But for this, it's just I would approve. I wouldn't say I wouldn't approve this, but I do approve this going forward. But I don't see anything that would stop it from going forward. So when Margaret's work on changing the way we encumber the funds would affect this project at this time. Follow me?
Yes, I believe I follow you, yeah. So we'll see what Margaret comes up with, but yeah, just to make sure we're all on the same page here. So we have a recommendation right now that the board authorize the GM to amend agreement W2876 with SPI Separation Processing for operational technical support services and increase the support services budget by $150,000. And we would modify that, if okay by Margaret, to be funded or encumbered out of designated funds or whatever the source is for a new not to exceed amount of $750,000. But also I'm hearing if that's not possible or doable, or if the full board wants to vote on it, we would just do it as is and have it included as part of the budget process for next year. So I guess we'll bring that back. At,
Well,
I mean, that,
go ahead.
you were going to say something, President Williams?
I'm confused now.
I'm confused too.
I am too.
So my understanding and what I'm supporting and what I'm recommending is that we move this forward, and that in that process that we take $150,000 out of reserves. Those are not committed to anything. That's reserves. I'm sure we've got $150,000 in reserves that will then be allocated to fund the project at the time that the extension's approved by the board in a couple of weeks.
Okay, no confusion here. That's what Margaret will look into, and if that's all the go, we'll word it as such.
Okay, is that okay with you, President Williams?
No, but I'll go along with it. Okay.
All right, so then we'll move on to the next item, which is 5D.
Okay, thank you. Item 5D, yeah, this is the last item on the of the four on the action calendar today. And this is pertaining to a recently completed project on the chlorine contact tank basins, which just very quickly, Kevin's going to explain this, but that is the sort of the last leg in the tertiary treatment process for Title 22, the disinfection process. So water comes in from Hyperion, it goes through filtration, flocculation, coagulation, then it gets filtered in the media, and then it gets disinfected in these big tanks that run alongside Sepulveda Boulevard, or now PCH. And these tanks were built in the mid-90s and a little bit later. So the project was the recently completed project was to replace a lot of gates that were inoperable, and the baffles, the internal baffles. These are tanks that are 500,000 gallons, so they're massive tanks, and they're in a serpentine formation, so they kind of like a maze. And the purpose of that is that the disinfection, which includes adding chlorine or bleach in this case to the water that's been filtered, and it has to stay in there for a certain amount of time. And then if it meets all those requirements, Title 22 requirements, it's ready for use as tertiary Title 22 disinfected water for our irrigation customers and feeds our 3 satellite plants. So this project was completed, and upon inspection of the interior of the contact basins that were rehabbed, some of the baffle walls were deflected or bent out of shape. So they need to be fixed and repaired. They do have some, compliance, component to this. The specific reason they're there is to ensure proper dispersion of the chemical, proper mixing, and to stop short circuiting. And there's, I think, 5, I forget how many there are, but maybe 24 or so. So yeah, this is to fix this deflection issue, and Kevin Cullen, our engineer too, who was our engineer on this project from the get-go. Kevin, can you handle the presentation, please?
Great. Thank you, Patrick. Good afternoon, Chairman Alvarez, members of the committee and board. As Patrick mentioned, I'll be providing a recommendation to our construction services agreement. That's with Pacific Hydrotech Corporation our contractor on board for the chlorine contact basin R&R project. Just to give a quick overview of the basins themselves, here's an aerial view of the Edward C. Little facility. Patrick mentioned they're in the southwest corner of the facility along Sepulveda Boulevard and Hughes Way there, right at the corner. There's 6 chlorine contact basins in total. They serve as kind of the last stop in the treatment train of our Title 22 water quality. That's our irrigation water quality that goes out to many of our customers, as well as all the satellite facilities. So very integral part of the process at the facility. These are underground basins, so when you're out on site at Edward C. Little, you can't really see much. All you see is a bunch of solar panels, but underneath those solar panels are 6 basins. Here's what they look like if the lid was removed. As Patrick mentioned, they're set up in a serpentine-like manner. You can see there, there's 1 slide gate for each basin that controls the influent water. That's followed by a dispersion wall that helps break up the flow and disperse it before it hits the first baffle wall. And then following the dispersion wall, there's a series of 4 baffle walls for each basin. And essentially what these baffle walls serve to do is to slow down the flow of water to provide the specified contact time that our Title 22 water quality needs to ensure proper disinfection. So across all 6 basins, they're capable of treating about 42 mgd. I think currently we push about 30 mgd through them. Each basin has 4 channels. They measure about 123 feet long, 11 feet wide, and 14 feet deep. So these are fairly large underground basins. Patrick mentioned the total volume is over 500,000 gallons, about 1.7 acre feet. So pretty significant volume there. And essentially what the project sought out to do was to improve the interior components of these basins. As Patrick mentioned, they were built in the early 90s in 2 phases, 3 as part of phase 1 and then another 3 as part of phase 2. So that was 1995 and 1997. So a lot of the internal components had reached the end of their useful life. So essentially we were going to replace all 6 slide gates, 1 for each basin, all 24 baffle walls, which were previously made of redwood, now installed with a more chlorine resistant fiberglass reinforced plastic, also called FRP. Also replaced the 12 mud valves. There's 2 for each basin that help drain down the water to facilitate cleanings, things like that, as well as the high pressure water supply piping that allows us to clean the interiors of the basin. So as Patrick also mentioned, the project is substantially complete now. The contractors completed 100% of the base scope of work. And overall, it was a great project, great success. We came in under budget and on schedule. Under budget in all 3 categories as well, which was pretty unique. We had under budget on the construction side, under budget on the CM side, and as well on the design side. So just wanted to also highlight a few of the construction elements. It was a pretty unique project in that really we couldn't begin any of the work until the slide gates were replaced. Some of the seating gasket material around the slide gates had begun to fail and wasn't providing a complete seal when the basin was closed and attempted to be drained down. So we actually used divers, and we replaced all 6 slide gates with the use of divers while the basins were in service. Pretty neat construction feat. And then moving to the second picture, here's kind of the end product of the project. We have a freshly cleaned basin with new baffle walls, new water supply piping, and cleaned out any muck or ferric chloride that's made it through the process train. Also worth noting, the entire project was, obviously it's an underground basin, so this is a confined space work environment, pretty challenging work environment. We were able to complete everything without any safety incidences or near misses. The third picture I have on the right here is more or less the subject of the presentation. You can see specifically the horizontal cross members for these baffle walls They help essentially support the baffle wall and account for any forces that the water are placing on the baffle wall. So specifically, we did find a somewhat of a shortcoming of these baffle walls and the need for additional fortification. So specifically, we'll be looking to add an additional horizontal cross member there. Patrick also did mention upon a final inspection by the CM team, unfortunately, we found some deflection in the first 2 baffle walls only. So as I mentioned, there's 4 baffle walls in each basin. Unfortunately, what we found, you can see that the inspection, the timestamp there is 125. So we noted this condition back in January. Immediately we took the basin offline and began looking forward and trying to figure out what the root cause was of this and what we could do moving forward to help improve operations. So ultimately what we found was that the forces from the initial filling of the basin created an excess pressure, an abnormal pressure essentially, and that pressure was greater than the initial design strength of the baffle wall. So it is a good thing we caught this now before the project was complete, and we completely released the contractor. We're able to engage them as well as the design engineer, the operations team, myself, and the construction management team, and together we've come up with a proposed solution that will fully fortify these baffle walls, will provide for a more flexible operation moving forward, and essentially, as I mentioned earlier, that solution is a 3rd horizontal cross member. So the forces that we're looking at when flow is introduced to these basins from an empty state condition, obviously the baffle walls are intended to slow down the flow of the water. So as flow is introduced with head pressure behind the gate, you see an influent flow of in the thousands of GPM. While there's only a limited amount of perforated holes that the baffles can flow through, or the water can flow through. Essentially, it builds up a bit behind the baffle wall, and what our baffle walls are currently rated for is about 18 inches of differential head pressure. After, as I said, couple months of detailed discussions with the design team, doing long hand calculations, calculating the forces, we realized that we did exceed that 18 inches of differential head strength. And we also did a pretty neat computational fluid dynamics model. And essentially what this does is we modeled the basins in real time. We mapped out the baffle walls, exactly how they're built, exactly how the channels are built. And through simulations, we found that we were exceeding about 20 inches of differential head strength. So looking forward, we've designed an improvement to our system. The new baffle walls looking forward. Here's a simple cut sheet of what the improvement will look like. It'll allow up to 48 inches of differential head pressure. Essentially, it'll create an operational environment that's fail-safe and a safety factor of well over 3.0. Yeah. So one thing also that we've done in coordination with operations is we've come up with a new specific operational protocol that'll allow us to maintain that chlorine residual per our Title 22 regulations, and that will allow us to meet our permit obligations and produce a high quality recycled water. So in the memo, we've outlined a lump sum cost proposal that we've received from the contractor. That's in the amount of $244,700. There's a breakdown there. The bulk of the cost is our new FRP beams. They're custom fabricated beams made of FRP, specifically resistant to chlorine and suitable for the environment that we're planning for. We do think there's an opportunity for cost savings, specifically with the labor component. We think with our understanding from the project and the way we've been able to work with the contractor, we think that we can reduce those costs up to 30 to 40%. So ultimately, the recommendation that I'm providing today is that the board authorize the general manager to approve the the specified amount, but that we proceed under a time and materials basis. And I think we'll be able to capture some additional cost savings there. So with that, I'd like to read the recommendation. Second. The recommendation is that the board authorize the general manager to amend agreement W2898 with Pacific Hydrotech Corporation in the amount of $244,700 to implement repairs and enhancements for a total not to exceed contract amount of $1,727,940. With that, I'd be happy to take any questions.
All right, thank you very much, Kevin. Any comments from the committee members?
Yes. Question. Now, is this amount, is this a change order to the contract or an amendment to the contract or what? And then follow up is, who pays for this?
Correct. Yes, this would be a change order to the contractor. We've been able to successfully issue 2 previous change orders using the approved contingency. We were able to address a few change conditions, a few extra points of corrosion and leaks in the basins. So we utilized the previously authorized contingency funds for those outside scope items. But yeah, as mentioned, we would be paying for this West Basin.
So what you have, we haven't determined who was at fault here with bending our brand new equipment here.
Yeah, Director Williams, that's an important part of this discussion, I think. They need to be fixed, obviously, for the obvious reasons explained by Kevin. And your question is very good. Who pays for it? Who caused this deflection, which could range from design to construction to operational, or a combination of all 3. And that's what we will definitely be looking into. We need to get them fixed, and we certainly want to pursue cost recovery once we identify fully the root cause, or if it was a combination of issues. So we definitely want to look into that very closely.
Okay, do we have in the project funding that's already been approved, the contingency amount will it cover this?
Director Williams, no, it will not. We have about $15,000 in remaining contingency as it stands. This amount would exceed that.
So you'd be asking for cost allocation to the project in order to get this fixed. So in addition to approving the amendment, you'd be asking for there to be an additional amount added to the contract costs. And where would that money come from? Has been encumbered and sitting around waiting for us to use it? So then we just go about collecting from somebody at the end to pay for it. We're looking for a reimbursement.
In the current fiscal year budget, we allocated $2.275 million. The awards for construction management services and the design engineer were just south of 1.9. So the awards for this project actually came in less than what we budgeted. The bids that we received were pretty favorable and were less than the engineer's estimate at the time.
So what I'm asking then is, do we need an additional amount of money to this contract to complete this?
Correct. That's what the recommendation is today, is to amend the contract in the amount of $244,700.
Okay. Thank you.
Do you have any other questions, President Williams?
That's it for now.
Okay, any other questions from the board members?
No, thank you.
Okay.
Chair Alvarez,
Yes.
hey, I guess I just have a clarification question because I want to understand again as I'm reading through here. So it says something about the baffle wall manufacturer confirmed each baffle wall has an ultimate strength capable of withstanding only 17.2 inches of differential head pressure. So can you just tell me one more time what exactly happened, Kevin, that these things failed?
Sure, no problem, Director Houston. So essentially, what we had included in our specifications was a design strength for a steady state condition.
Mm-hmm.
Essentially, when we introduce flow back to the basins, remember these basins have been in service for over probably the last decade and haven't been taken offline. So when we reintroduce flow, that pressure on the baffle wall was just north of 20 inches. While the design strength was 17.2 inches. So ultimately that's identified the need to kind of refortify our baffle walls and improve the strength. So in the years to come, we'll be able to fill these basins more quickly, and maintain that chlorine residual. If we were to, just trickle the flow in, you could have product water with somewhat of a stale chlorine residual or a lower chlorine residual if you introduce flow slowly. So there's a need to expeditiously fill the basins and get it into the product tanks and out into the distribution system. So.
Okay, I mean, that's okay, because I thought I heard something mentioned about the 20 inches versus 17.2. So that answers, well, I'll just make a comment, and I think, probably Director Williams and Director Alvarez have more knowledge on this, but I don't understand where the fault lies in all of this. Obviously, it sounds like we're the ones that are going to pay this and figure out, if we get reimbursement somewhere. But obviously, if we should look at reimbursement, I would highly support that effort. So, but that's my questions for now. So thank you.
All right. Any other questions from any other board members?
Yeah, I'd just like to say that in incidences like this, that in the fiscal impact should indicate that there is an additional allocation needed to complete this project. Although we're going to pay for, we won't stop the payment to get the work done, but after it's all said and done, we need to recoup the extra, the additional, what is it? The 244,700. That has to come out of somebody's pocket. It shouldn't come out of ours.
Yeah, agreed. And we can add that to the fiscal impact, Director Williams, President Williams, that the recovery of these repairs, the cost recovery will be pursued by the district.
Okay, with that, then I would, if you're ready for
Okay.
action on this.
I've got a couple follow-up questions with respect to your comments, President Williams. But first, who prepared the plans and specifications for this?
The engineer we have on board was utilized under our on-call agreement. That'd be M&S engineers.
Okay, so M&S engineers designed it?
Correct.
Okay, and the intent of the design was basically that these baffles would be operating under static conditions where the flow rate up and down the channel walls or between the channel walls would be at some fairly small or fairly low velocity.
That's correct, Director Alvarez, and I think that's where the
Okay,
real
and-
disconnect lies is, you know. Excuse me.
So I'm just going to the cause of why they deflected. They deflected because it wasn't designed to basically take, you guys flooded the basins, and when the basins were flooded, you basically had a wave coming through, and that exerted more pressure than the velocity would if those basins were full.
Not quite. I think I can shed more light on this for you. So essentially, the baffle walls were designed around a steady state condition. When these basins are full, it takes the water about 45 minutes from when it enters the slide gate to the time it goes out over the outlet weir. So, as you mentioned, it's a pretty slow flow of water. Under a steady state condition, the baffle walls really only see anywhere from 2 inches to 4 inches of differential head. So that's what they were designed around. I think the disconnect was the oversight on the actual forces when filling the basin. So as I mentioned, these basins hadn't been operated in 10 plus years. Previously, we had redwood baffles installed. Suez has a specified protocol that they use. It's 25% open. You open the gate slowly. It takes 15 plus minutes to even get to 25% open. It's over 300 turns on a hand wheel. So it is a slow introduction of flow, and we're talking the forces that would have put in excess of 20 inches of differential head would be merely opening the gate 1 to 2 inches on a 36-inch gate. So it really is quite the amount of force that comes in when you introduce flow.
Okay. The other question is following up on President Williams' question about the budget. Kevin, you mentioned that the whole thing's coming under budget. So how much money is currently been encumbered or is in the budget for the project?
Yes, in the memo in Table B, we have everything summarized there. In the current fiscal year budget, we've budgeted approximately $2.275 million. In total, we awarded contracts worth $1.1879 million. There was a few minor change orders to address additional items of corrosion that were found in the basins, or leaky expansion joints in the underground basins. So we addressed those during construction, and to date, we've expended just over $1.9 million.
So with this 244,000, you'd be basically at 2,144,000.
That's correct.
And you've got budgeted in the current fiscal year budget, the FY 2020-21 budget, you've got 2.75 million.
We have.
Go ahead, Kevin.
Looking forward, because there wasn't a 12-week lead time on these new beams. The baffle wall manufacturers worked with us to get it down to 6 to 8 weeks. But given the timing of the board cycle and when the work would actually be implemented, we've carried over the additional funds into next year's capital improvement program as the work will take place over June and July.
Okay, but the funds are already budgeted. 2.75 million is in the budget.
So let me, Dr. Alvarez, I can answer that. The 2.275 that you see on Table B was the basis of what we budgeted this project for the fiscal year. This is one of the projects that are multiple years, of course. And so if you open up the capital budget book for this year, there's around a little over $1.5 million, but that's only because this project is over multiple years. But that 1.5 that was included in this year's capital budget was based on this multiple year $2.2 million. So with this addition, with this 244,000, we would still be a little less than the 2.275 that was the basis for this year's capital budget.
Okay. So if I understand that the answer that is that it is in the budget. In other words, the
Correct.
budget is 2.275, and as we said earlier, you're not going to be at that number with the additional 244,000. So the money is in the budget.
It is.
Okay. Thank you. If there's no other questions, then should we move this forward to the board, President Williams?
Yes, we should, but we should make sure that someone else pays for the actual costs of these repaired baffles, because we bought new gates, not repaired gates. So we need to get that money.
Okay, with that caveat, let's move this forward to the full board. All right, so with that concludes the action calendar, and let's move on to the information calendar. It's been a little bit longer than I thought we were going to take to go through the action calendar. So in the information calendar, if we can just move forward right now to item 6D and go over the existing treatment facilities overview, and if there's time, we can then go back to the other items on the information calendar.
Okay.
So, General
Chairman Alvarez, do you
Manager,
want me to introduce that item?
I'm sorry?
You want me to introduce item 6D?
Yes,
Okay.
item 6D.
Yes, item 6D. So, yeah, this is an item that actually Chairman Alvarez asked to have us put on the agenda. And the high-level overview of it is to look at all of our treatment processes and one of our major facilities, which is a Hyperion pump station as a facility. It's not a treatment process. And then the EDC Little plant and the 3 satellite plants. So look at them with a view to capacity and what happens at each part of the process once you get into the plant. Where does the water go? It goes from here to here, and then where? What's the treatment flow process look like? And we have attempted to, staff has attempted to put all of that together with a lot of historical data on flows and other data for context. So we have our engineer here, Orlando Rodriguez, and we have some folks, I believe, here from HDR on the line too. But Orlando's going to present a PowerPoint presentation, which hopefully you got yesterday or today, to walk us through the existing recycled water treatment flow, sort of from a process standpoint, from beginning to end. So Orlando?
Yeah, thank you, Patrick, for that. Could everybody hear me and see my screen, the presentation?
Yes, go ahead, Orlando.
Perfect. Thank you. So good afternoon, Chairman Alvarez and the members of the committee. As Patrick just mentioned, on March 15th, a special board meeting was held to give an update on the recycled water master plan. As a result of that meeting, followed by the request by Chairman Alvarez on April 5th, this presentation is a follow-up to the master plan update focused on an overview of West Basin's existing recycled water treatment facilities. Now, please turn to slide 2 of your presentation handout. So as part of the master plan process, an evaluation and assessment was performed of all of West Basin's existing recycled water facilities, from pump stations to the treatment facilities and the recycled water distribution system. The Hyperion secondary effluent pump station, located at the southwest corner of the Hyperion water reclamation plant, provides a secondary effluent from Hyperion to the Edward C. Little water recycling facility. West Basin currently operates 4 recycled water treatment facilities. The Edward C. Little water recycling facility is located in the city of El Segundo and is the largest water recycling facility of its kind in the nation. The 3 remaining recycled water facilities, often referred to as the satellite facilities, include the Chevron Electrification Treatment Plant in El Segundo, the Juanita Melinda McDonald Carson Regional Water Recycling Plant in the city of Carson, and the Torrance Refinery Water Recycling Plant in the city of Torrance. West Basin also operates the recycled water distribution system. That includes pipelines, booster pump stations, a barrier blending station, disinfectant station, and brine lines. Although, as Patrick earlier mentioned, the Hyperion secondary effluent pump station is not a treatment facility in its own right, we thought it is important to include in this overview, as it is the sole source of secondary effluent for West Basin's recycled water program. Now, please turn to slide 3 of your presentation handout. So as it stands, West Basin currently produces 5 types of designer water to meet its customers' needs, from oil refineries to golf courses, parks, and many others. Disinfected tertiary treated water, often referred to as Title 22 water, is mostly used for irrigation purposes and some industrial applications. Nitrified water, which is essentially ammonia-free recycled water for cooling towers, low pressure boiler feed water, and high pressure boiler feed water for the refineries, and groundwater replenishment water, also referred to as barrier water, for use in a barrier against seawater intrusion. Here on the right of this slide here is a kind of a process flow schematic, which is actually attachment A of the staff report, that shows really a simplified interfacility process flow schematic with the various types of designer water produced at the treatment facilities. Now, please turn to slide 4 of your presentation handout. So here, shown now is a simplified diagram showing an overview of the kind of recycled water process and the designer water produced at each treatment facility. At the start, a portion of the Hyperion water reclamation plant secondary effluent is pumped by the Hyperion secondary effluent pump station to the Edward C. Little facility. The Edward C. Little facility produces 4 types of designer waters: barrier water for WRD, for the seawater intrusion barrier, low pressure and high pressure boiler feed water for the Chevron refinery in El Segundo, and Title 22 water for irrigation customers, as well as to convey to the satellite facilities for further treatment. Then you have the Chevron nitrification treatment plant, which produces nitrified water for the Chevron refinery. The JMM Carson plant produces low pressure boiler feed water and nitrified water for the Marathon refinery in the city of Carson. And the Torrance plant, which produces low pressure boiler feed water and nitrified water for the Torrance refinery, which is currently owner operated by the Torrance Refinery Company. Now here on the right of the slide is a exhibit that shows our recycled water distribution system pipelines in the purple lines, as well as some of the our treatment, not just the treatment facilities, but the Hyperion secondary effluent pump station here shown on the kind of western most point. If you go a little bit east, you see the Chevron nitrification treatment plant, as well as the Edward C. Little facility in the city of El Segundo. As you go a little bit further southeast, you then see the Torrance refinery water recycling plant. And further east of that facility is the Carson regional water recycling plant. Now, please turn to slide 5 of your presentation handout. So West Basin's facilities have different treatment capacities, which refers to the actual finished water qualities produced at each facility. Here in the table, you see these are the existing capacities for each of the treatment facilities, and also the kind of correlating infrastructure for the treatment processes, which I will go into greater detail a little bit later in this presentation. Now, please turn to slide 6 of your presentation handout. So as previously mentioned, the Edward C. Little facility is the only treatment facility that receives a secondary effluent from the Hyperion secondary effluent pump station. built in 1994, the original pump station includes 4 vertical turbine pumps with a firm capacity of approximately 51 MGD. Improvements to that pump station were recently completed in 2019, which added 3 new vertical turbine pumps with a firm capacity of approximately 40 MGD, and also provided a secondary power supply source for increased reliability. Between the years of 2016 and 2019, the annual flows averaged about 36.8 MGD. The pump station sends a secondary effluent to the Edward C. Little facility via a 60-inch PVC lined reinforced concrete force main.
Orlando, if I could interrupt you, I have some questions, and I know that this is a pretty long presentation.
Sure.
So I'll just ask questions as we go along, and other board members and committee members, if you have questions, I think it'd be best to ask them. You probably tend to forget as the presentation moves forward. So with the new pumps that were added, and they were added about 3 or 4 years ago, or fairly recently, the total capacity of the system in terms of the source water supply is 90 MGD.
So are you?
My question is, if we were going to operate at the maximum that we could operate, what can we operate at?
Unfortunately, Director Alvarez, the 51 MGD and the 40 MGD, I think that's where you got the 90 MGD. That's not necessarily additive. The firm capacity really is a total of about 60 MGD. That is really based and limited by the power supply at the pump station right now. So we can't necessarily run all the pumps at the same time. Does that answer your question? Okay.
That answers my question. That was what I was looking for clarification.
Okay.
Because in some areas, it talks about the fact that there's 90 MGD capacity at the pump station, and I just wanted to clarify that there may not be a full 90 MGD capacity. That if you add up all the pumps, theoretically, they add up to 90 MGD. So on a consistent basis, can you operate at 60 MGD?
I believe so. Sorry, Kirk Barkat?
I would just, Mark, if you can answer the question. So there's a couple things you want to clarify here. The firm capacity is indeed 60 MGD. If the power supply issue that's causing part of this restriction was addressed, how high could we go on firm capacity?
Yeah, on firm capacity. So again, just to clarify, what does firm mean? Firm means that one of the largest pumps that you have is off. It's on standby. And we always assume that because you're cycling pumps. So this 40 and 51 is assuming on each section of the pump station that one of the pumps is off. If you take all the pumps from the older pump, the 4 old pumps, that's a total of 70. And then you take the total of 3 pumps, the newer ones, a total of 60. But and then you take one of the pumps from each one out, that gives you the 90 over here that you see in front of you. So if there was not, to go back to answer the question, Patrick's question, if there was no limitation on the power, pumping wise, with firm capacity, with 2 pumps out, you can go up to 90.
Yeah, but the firm capacity, if I was going to operate this plant, because I'm feeding water to a treatment plant, what's my firm capacity 24/7?
Today you can operate with the power limitation that we have. You can operate only 3 pumps at a time. So that could go up to 60 MGD to answer your question.
Okay. So that everybody understands, because sometimes we go back and forth between MGD and acre feet per year. When we said 50 MGD, we're really talking about a little over 50,000 acre feet a year.
Yeah, 60 MGD.
Yeah, but
One
an
MGD
acre
is
feet per
about-
year, it's about 55,000 a year.
1 MGD is 1,100 acre feet.
Correct.
Okay, so assuming that the pumps are working, what we can produce at a maximum is about 55,000 acre feet a year.
That 60 MGD is
Or
67,000.
60, about closer to 70
Yeah,
acre feet.
67,000 acre feet per year.
Okay. So in terms of total water demand, and then we wouldn't be producing out of that. We'll talk that in more detail as we get into the treatment plant. So that's not going to be 100% production because there's backwashed water, etc. So you, of all the water we're pumping into the plant, not 100% of that becomes product water. But we're maxed out right now at 60 MGD, right?
Correct. With the power limitation, yes.
And if we didn't have power limitations, could we increase that? And what would it take to overcome whatever the power limitation is?
We would have to look at that. What would it take to overcome the power limitation? In addition to the power, Dr. Alvarez, on the force main itself, we've done a surge analysis, I think it was a couple of years ago, that looked at 60 MGD going through the force main. And I think there were some recommendations if we were to kind of go to 60 to implement a few modifications to the force main. We would have to revisit the surge analysis to see how it can handle the 90 MGD if we were to ever go to that.
Okay, so just so that I understand it, because I may have misunderstood you previously. We could go to 90 MGD with the pumps that we have there if we had more power available at the plant?
Correct.
Yes.
Okay.
And we have to confirm the other limitations on the force main from a surge perspective.
Okay. So assuming that we got to 90 MGD, but right now really it's 60 MGD unless we increase the power source at the pump station.
Correct.
And at 60 MGD, the force main may or need some to be revisited, or it's.
I think my recollection is it could have handled 60, Orlando.
Yes, it could handle 60. There are some recommendations, some valves to be installed along the force main and things of that nature. Perform an assessment, and I think anything beyond 60 would need further study and analysis. So I think in the surge analysis, it looked up to the 60 MGD, but there are some recommendations already made. If we were able to, if that was the demand, but anything beyond that, I think the surge analysis did recommend performing even further studies and assessments.
Yeah, I looked up some of the data. The 60 could be handled by the force main. The air vacs are recommended around 65. And then as far as the electrical upgrades at the plant, we would need a second transformer installed and potentially other improvements as well.
Mr. Chair.
The source of power is the city of LA, right? LADWP?
Yep.
Mr. Chair.
Go ahead, President Williams, you have a question?
Director Houston online, because due to a previous engagement here, I'm out of time, and the subject matter is a little TMI for me, but I think I'm going to have to turn my seat over to Director Houston. Are you here, Director Houston?
Yeah. Yes, I'm still here. I can go till about 7 o'clock.
Okay,
I'm here.
well, thank you. I have to bail now. Thank you. The
Okay,
action items have been taken care of, correct?
President Williams, hopefully you have a good evening.
Thank you very much. Good night, everyone.
Good night.
night, Director.
Chair Alvarez, I have to leave at 6 because I have a 6 o'clock. So in about 5 minutes, I'm gonna have to tune off also.
Okay, well, thank you for
Thank you.
letting us know, and you have a good evening also.
Thank you.
We probably should have cut some of the earlier ones a little bit shorter, but so it is. And maybe we won't get through this entire presentation this evening. And I didn't think that the action items were going to take as long as they were going to take. But this presentation can go on because I'm really trying to clarify how much capacity and where we have capacity in the system and what is the nature of the investments we need to be making as we look forward into the future. So there will be questions, and this is a substantially a substantial item, I should say, that can take some time to get through. So theoretically, we could produce up to 90 MGD if we had additional power, which primarily, if I understand you correctly on this now, it's a transformer that needs to be installed. Okay.
Yes,
And then we do have an emergency generator at that pump station, or we do not?
yes. There was yes, that was added as part of the improvements that were recently completed.
So I don't think that the emergency generator is going to be that huge, but if power went down and you needed the emergency generator to kick in, so what's the emergency generator capable? How many pumps are you going to be able to run off the emergency generator?
Kevin, Kevin Cullen, are you still with us? Kevin was the project manager for the pump station. He might be able to weigh in.
Sure. Yeah, Mark, if I can help out. Off the emergency generator, ironically, it's a bit stronger than our current transformer. We have a 34.5 kilovolt transformer out there. So the utility transformer can power 3 800 horsepower pumps, and our emergency generator can power 4 800 horsepower pumps.
Really? The emergency generator is more than the power we have available at the site?
Yeah, it's a massive
Yes,
generator.
looking forward to the future.
That's a twist, not a nice twist, but a twist.
Yeah, not the norm.
Okay, so just going back to it, so today we're basically maxed out at 60 MGD.
Mhm.
Okay, all right, go on and let's start talking about the Ed C. Little plant.
Do you want me to jump ahead to the Edward C. Little plant, Director Alvarez?
Yeah, because I think that's your next slide, isn't it?
Well, the next slide is actually talking about the influent flows. So,
Oh,
but
okay.
I think
Yeah,
it's about
go
2
ahead.
slides ahead.
Go ahead. Just follow your presentation.
Okay. So just to kind of continue on where I left off here on the force main, the force main construction of the force main was completed in 1995 and is approximately 2.93 miles in length, max capacity of about 89 MGD. Obviously, we just kind of touched on that. We need further analysis, but the surgeon analysis kind of stated is we just need to assess this further. And here, if you follow me to the exhibit on the right, it shows the kind of pipeline alignment of the force main, starting at the Hyperion pump station, at the Hyperion water reclamation plant, then just kind of traveling south on Vista Del Mar into the city of El Segundo, along Grand Avenue, El Segundo Boulevard, and then just kind of south into the Edward C. Little facility. Please turn to slide 7 of your presentation handout. So here at the Edward C. Little facility, the daily average influent flows from the Hyperion pump station range from 20 to 35 MGD between 2010 and 2015, and about 25 to 45 MGD between 2016 and 2019. And that's actually displayed here at the figure on the left. Just a few things that I kind of want to point out here is there are some kind of anomaly data points that were eliminated from the data set. These points are kind of outside of the trending flow points here in the red, and also some of them actually correlate with some events that happened along the way, and therefore caused some of these anomalies. So these were eliminated from the data set here. Here on the figure on the right shows the kind of influent peak around the flows that peak around the kind of late summer to early fall, and typically dip around winter to early spring, somewhat suggesting a correlation between flows and the seasons. All right, now please turn to slide 8 of your presentation handout. So here you see the aerial of the Edward C. Little facility. Construction began on the facility in 1994 as part of West Basin's Phase 1 water recycling program. With the subsequent construction of Phase 1, the facility has experienced 4 additional major construction phases for a total of 5. Here I'm going to kind of show some animations that show the phases of construction at the facility. Here in the kind of purple elements show the kind of Phase 1 infrastructure at the facility. Phase 1 was completed in 1995 to provide 15 MGD of Title 22 water and an additional 5 MGD of barrier water. Phase 2 infrastructure is shown here in the green elements. The Phase 2 construction was completed in 1997 and added 15 MGD of capacity to the Title 22 system for a total of 30 MGD. An additional 2.5 MGD of capacity was constructed for the barrier system for a new total capacity of 7.5 MGD. Here in the kind of orange-red elements is the Phase 3 infrastructure facilities. Phase 3 was completed in 2001, adding 4.3 MGD of single-pass RO water and double-pass RO water for the delivery to the Chevron refinery. And then here you see in the yellow elements here is the Phase 4 facilities. Phase 4 was completed in 2006 and increased the Title 22 production capacity by another 10 MGD for a new total capacity of 40 MGD. 5 MGD of RO capacity was also added for a total of 12.5 MGD. And additional MF and RO units were constructed in anticipation of future deliveries of up to 17.5 MGD of recycled water to the barrier. And last but not least, here in the blue elements, we show the Phase 5 facilities. The Phase 5 expansion project was originally completed in 2012, in which the barrier water maximum production capacity was increased from 12.5 MGD to 17.5 MGD. The single pass and double pass RO water system was expanded to provide about, I would say, half 0.47 MGD of single pass RO for the NRG Energy's El Segundo power plant. And then recently in 2018, West Basin improved the original Phase 5 system by adding 2 additional MF racks to improve reliability. Now, please turn to slide 9 of your presentation handout. So,
If I can interrupt you, Orlando, can you do
sure.
me a favor? You just went over all of the different expansions and the capacity that was added. And I think it kind of shows up in some of your slides coming up. But could you tabulate basically the summary you just presented and send that to us at your convenience, please?
Sure, no problem, Director. Let's see. Okay. All right. All right. So anything else? I'll go ahead and continue.
There will
Okay.
be some comments, but keep going. You're doing a great job.
All right. So the here, the Edward C. Little facility performs different treatment processes to produce 4 different types of designer water. I'm just gonna say now, I'm gonna go into a little bit of detail right now, explaining exactly what happens. And so for the Title 22 treatment process, influent is a mix with a treated filter backwash and a dose with a coagulant and flocculant prior to entering the high rate clarifiers. Solids residual flows from the high rate clarifiers go to the solids handling building for thickening, hulling, and eventual disposal. The return waste flow is overflow from several smaller high rate clarifiers that treat backwash waste and MF concentrate generated on site. High rate clarifier effluent flows then enter into the tertiary monomedia filters prior to the chlorine contact basins. Effluent from the chlorine contact basins is then stored in 2 5 million gallon on-site storage tanks until it is eventually conveyed to the Title 22 system, and also the conveyed to the satellite facilities. Now, for the MFRO process, influent is dosed with ozone and enters a contact basin prior to the MF treatment. After ozone pre-treatment, flow is also dosed with chlorine that combines with the ammonia in the secondary effluent to create chloramines prior to entering the MF membranes. MF effluent is first collected in 2 holding bases, an intermediate storage basin, and a clear well prior to being pumped to the RO trains for further processing. MF effluent is dosed with sulfuric acid and a scale inhibitor upstream of the cartridge filters to lower the pH and mitigate silica sulfate scaling. RO feed pumps pressurized flow to 11 RO membrane trains. Then a single pass RO permeate is then split to 3 downstream treatment processes. One being an ultraviolet and advanced oxidation process, abbreviated here as UVAOP. It's a system that doses hydrogen peroxide with UV photolysis for advanced oxidation, which destroys any kind of harmful trace constituents. The UVAOP effluent then passes through the decarbonators to raise the pH, sodium hypochlorite dosing to provide chlorine residual, and is then pumped to the barrier system. Second stream is a RO permeate, also flows into separate decarbonators that raise the pH of the RO permeate before it is pumped to the Chevron refinery as a low pressure boiler feed. And finally, a portion of the low pressure boiler feed is sent to second pass RO facilities before being pumped to the Chevron refinery as a high pressure boiler feed water. Any questions? Director Alvarez, looks like you were going to ask a question.
Yeah, I've got some questions, and I'll try to keep them short because, time's going, and I don't want to keep here everybody tonight for the whole evening. Go back to the Title 22. So all of the water before it goes into the individual designer water treatment is Title 22 water. And the capacity, is that the case or that is not the case?
Did you say, is that at capacity?
Well,
Sorry.
Orlando, let me just cover that. So all of the Title 22, Director Alvarez, all that Title 22 water exits the plant and goes to the satellite facilities or the irrigation applications.
Okay.
The microfiltration and subsequently the RO, they're fed directly with secondary effluent straight to microfiltration, then RO. They don't go through the tertiary process. And that water, and the same for the barrier water. So that portion doesn't go through tertiary treatment.
Okay, that's what I need, what I was looking for clarification on. So then on the Title 22 water, what's the capacity that we've got currently?
About 40.
40 MGD.
40 MGD. Okay, and then on the MFRO water, which is the barrier water, and that's 100% of the barrier water, correct or not correct?
No, the MFRO is for barrier and for Chevron.
Yeah.
Okay, for barrier and Chevron. And so what's our capacity there?
For the barrier, it's 17.5 MGD instantaneous, meaning that's if everything is blowing, and then if a portion of that, if we can use a portion of the Chevron capacity membranes for the barrier. So it's 17.5, but under normal operation, it's about 16 or a little bit less.
So
And then on
kind of going back to using the terminology firm delivery, it'd be about 16 MGD.
roughly speaking, that would be our max in a normal steady condition.
Okay, and then
for the Chevron, it's around the max capacity on the Chevron. I believe it's around 4.8 for both high pressure and low pressure feed combined.
That's correct, and these are all on slide 5, a table that has all of them laid out.
Yeah, they're coming up.
okay,
Actually,
so slide 5 has all.
Yep.
Let me go back to slide 5. All right. So on the barrier water, then you're saying that on firm capacity, you're looking at 60 MGD. Why is it that we still aren't delivering 100% recycled water to the barrier?
Good question, Director Alvarez. That's coming up too. Orlando, I'll give you first shot on this. Go ahead.
Yeah, so the demands are actually controlled by the LA County, Director Alvarez. They demand the water for the let me go to slide 5. I'm sorry, just quickly so we could see. Oh, sorry. So yeah, so just like I mentioned, the demands actually come from LA County for the injection for their the well system for the barrier. So we don't actually necessarily send the maximum amount that we're capable of. They demand it, and then we send it as it is demand for the system. So that, I think, subsequent slides, I was going to go over that. But that's been averaging about 12 to 14 MGD. So we could send more, but it's not controlled by us. Essentially, it's controlled by the county.
Okay, but 100% of the water that goes into the barrier is purchased from West Basin Municipal Water District.
Correct.
Correct. Mm-hmm. So why? I understand that the county operates the barriers. I understand that the county will say we're going to shut down part of the barrier, so we're not going to take water for X amount of period or take a smaller quantity of water. But why is it that we're still selling imported water and not 100% MFRO water to the barrier?
Okay, let me take a shot at answering that. Good question. So just not to belabor the point about the county dictating the amount, they're following a level in the aquifer that they don't want to exceed and they don't want to go below. If they go below, they need more water, and if they go too far below, you have seawater intrusion. So they're chasing this level. And as you pointed out, there's also variables like how many of the 157 wells in the north and south leg are in or out of service at any given time. So we're kind of chasing that goal given by the county. As far, and I see Susanna popped on there, as far as the imported water, they like a small amount of water to be blended with our recycled water. And Susanna, if you want to explain, that's a sort of a, they have their own reasons for that. It's a small amount, but that's also not our choice. That's coming from them.
Yeah, I hear echo.
Go ahead, Susanna.
Okay, so in the past, you've seen that we've been injecting potable or imported water. That's to what Patrick and Orlando mentioned. It is controlled by the county, but in the past, due to like maintenance issues that we have at our plants, so at those times we weren't able to provide that maximum 16 or 17 and a half MGD of capacity. So you see the historical injection rate where we have imported water. About those in the previous times, it was due to partly maintenance issues within the plant, or as well as from the county, they had to bring down wells, and that they can allow for just recycled water injection. So and as Patrick mentioned, they do want to ensure that the potable injection system is functional. So at times they are requesting that some portion of imported water to be injected into the barrier. But talking to WRD just last week, they are wanting and anticipating 100% recycled water as much as we can allow them. So we're working toward that. And actually in October 2020 and till now, we are meeting nearly 100% recycled water injection currently.
So just as I understand the fluctuations in demand for barrier operation. My concern has always been that if we should be providing 100% recycled water to the barrier and not using imported water. So if I understand, and maybe I'm misunderstanding this, part of the reason that we did not provide 100% recycled water to the barrier and that we've ended up having to provide imported water is because the plant is not working properly or wasn't able to produce at the capacity that was needed at the time to meet the barrier demand?
Yeah, so if you remember, like we gone through different phases of microfiltration expansion, and at the design criteria for the plan, we were looking at like 20 years ago, the ammonia level was at 25. And as we expanded, I think during the earlier phase, the water quality creeps up and the ammonia level went up, and the design criteria didn't really match up to the water quality at that time. By the time the new phases of equipment brought online, the existing equipment, you will, they weren't designed for that higher ammonia level. So we saw a lot of fouling issues that we encountered at our plant, and corrosion issues that now beginning to affect our treatment equipment. So that brought up a lot of maintenance issues that always had been like preventing us from operating at that maximum capacity. So we've been working with the phase 5 expansions, and we've addressed a lot of those issues. So we're at a point we feel comfortable that we'll be able to provide 100% recycled water demand going forward. Although I have to say that we're still working some minor issues that are still existing. So, but at this point, we are at 99% recycled water injection rate this past month. So
Okay, so it would behoove us though to go to 100% recycled water as a barrier. The whole point is to avoid use of imported water. And WRD budgets for 100% recycled water. If you look at their annual budget, they're looking, and they've always said, I thought we were getting 100% recycled water. So that's the expectation for the barrier. And we've had some operational issues, but you think that we're going to be able to get beyond that and be able to deliver 100% recycled water at the barriers.
Yeah, there's been historically, years ago, some operational issues, but the main driver again is what the county will allow us to put in there. Like today, Susanna, could we put in more than they're asking for?
currently, they're having a well rehab project, so we're sending 11 MGD currently. If they want to increase that capacity, we will be able to meet that at least to 14 to 15 MGD of capacity.
I get the point about the operational constraints that the county puts on. That depending on how many wells they got operating, etc., that fluctuates. My concern is that we serve 100% recycled water in the barrier.
Director Alvarez.
That is the capacity currently.
Yeah,
The 11 MGD.
We can, while serve 100%, maybe I think the county has indicated to us in the past that for certain operational reasons, meaning the operation of the valves or the velocity in the pipelines, to make sure that there's at least a little bit of potable water still moving. So that's one aspect, but that's just a little bit. So it might not be exactly 100%, but very close to 100 is what we try to achieve.
Remember that the water you're putting directly into the aquifer is potable water.
Right.
Okay. So the only reason we wouldn't be putting 100% recycled water is because we've got some limitations at the Ed C. Little plant in producing that water.
As Susanna mentioned, we've had some limitations in the past. Right now with the capacity, if you can see the trends, and we'll be happy to kind of bring back the trending over the years on how much recycled and how much potable went into the barrier. We've done that presentation. I think the last time we did it was in December, showed the mix of recycled to potable that went into the barrier. We can certainly bring that back and kind of show you that in recent years, we've been very close to 100% of the demand.
Yeah, right. I think Susanna, you just said that what was for the last month, what was the percentage of what we were allowed to send? How much of it was recycled water?
We're above the 99%. So there was some reading error on the county part because they one of the existing barrier blend station project that unfortunately they lost it. Well, preventing them to look at some of the signal on the meter, and that makes inadvertently the county had injected more potable water than they intended. So otherwise, we are able to meet 100% recycled water demand right now. So.
Thank you.
So right now we have, but last year we didn't sell 100% imported or recycled water. We had a mixture of imported and recycled water.
Correct. Vast majority, though, like Barkev said, let's bring those totals back. Vast majority, Director Alvarez, as I recall, is still recycled water. Very high percentage, but not exactly 100.
Okay. It's just that as we move forward, we pride ourselves in being a agency that wants to move and replace imported water with recycled water, which is really the goal that we should all be trying to achieve. So I just want to encourage us to continue in that fashion. And if the limitations are in our treatment processes, then we need to address those. And that's what I'm trying to get a handle on.
No, very, very good points, and that's certainly our goal. When this project started in 1995, it was 50% imported, 50% recycled water. Then it went to 75%. Now we're at 100%, and usually, barring any things that Susanna mentioned, we can do that if allowed to put 100%. But certainly, yeah, that's definitely the goal, I think, of everybody. That's one of the things we're proud of all that imported water that used to go into the barrier. 100% is predominantly recycled water now.
Going back to the capacity, the barrier, like if you say 100% is 17.5, but there's no redundancy built into that. So I just want to point that out. If we want to have a sustainable 17.5 as a 100% goal, we'll need additional RO trains.
That's my question. Thank you. Okay, Orlando, move on.
Okay, we'll add that to the capital program, Desi.
Well, there's the big question of, where are we headed? Go ahead, Orlando.
Okay, let me just go back to the slide that I left off. All right, so here, okay, so it's kind of like where I left off. So I'm still talking about the Edward C. Little facility here. I think actually, I think I talked about this slide. Sorry, Director Alvarez. I'll just go over it again just to be on the safe side. So here, the figure on the left displays the Title 22 product flows between 2010 and 2019, which ranges from 12.5 MGD to 25 MGD. The figure on the right here specifically illustrates product flows from 2016 to 2018, which shows seasonal variation here. Title 22 product flows peak during the summer months and dips during the winter months because irrigation users utilize more water during the hotter months. Now, please turn to slide 11 of your presentation handout. So I know we kind of went over this a little bit right now, but I'm just going to quickly recap the barrier water. So as mentioned, the Edward C. Little facility produces barrier water delivered to the LA County's well system, which is injected into 157 wells connected by approximately 9 miles of pipeline, all the way from the city of El Segundo down to Palos Verdes. Here on the figure on the right, it displays the barrier water product flows from 2010 to 2019. Demands, I think we were saying the barrier water typically do not display any kind of seasonal patterns, and as we just mentioned, it's controlled by the county and their demands. And as Barkev mentioned a little bit earlier, here in the other bullet point, we have the capability of an instantaneous capacity of about 17.5 MGD. And recently, the typical product flow range has been between 10 and 14 MGD. All right, now please turn to slide 12 of your presentation, or unless Director Alvarez, you had further questions? I don't know,
No, I think we covered that.
Okay.
As we move forward, we're going to really need to focus, if we want to go to 100% recycled water as the barrier, increasing the firm capacity. And that discussion we just previously had got us to that point, that we don't have that capacity yet.
Okay.
There are members of the public out there, believe it or not, that think we're 100% recycled water. And it's like, no, we still import quite a bit of water even though,
Director Alvarez, for the amounts of water that they asked for, we have the capacity for it.
go ahead.
Okay. So going on to, please turn to slide 12 of the presentation handout. Continuing the discussion here for the low pressure and high pressure boiler feeds to the Chevron refinery. Here the figure on the left illustrates the low pressure boiler feed product flows between 2010 and 2019 with a range from 1.5 MGD to about 2 MGD. While here the figure on the right illustrates the high pressure boiler feed product flows during the same time span, ranging between 1.8 to a 2.6 MGD. And just to note, the kind of boiler feed product flows do not exhibit any seasonal variations because they, typically depend upon the industrial demands at the refinery. So now please turn to slide 12 of your presentation handout. So as a result of the kind of RO process, an RO concentrate is produced containing nutrients and organic compounds that is considered a waste stream. At the Edward C. Little facility, the RO concentrate, also referred to as brine, is conveyed through a brine line to the 5-mile Hyperion ocean outfall. The brine line is a 18-inch outside diameter HTP pipeline, approximately 3.39 miles in length. And from 2016 and 2019, brine flows average about 2.9 MGD. Just one thing that I do also want to note here, when considering any kind of RO membrane expansions, at Edward C. Little, we do want to give consideration to the maximum capacity of the brine line. But just to caveat that, we do have capacity right now. So just a thing to note when we do any kind of RO expansions at the facility. So here at the figure on the right, just also a showing the kind of pipeline alignment of the brine line, and you'll probably notice that it mimics the force main alignment. The real difference here is, the pipeline actually goes further north beyond the Hyperion pump station, then ultimately reaching the Hyperion ocean outfall.
So we pump directly to the outfall?
Yes.
Yeah, it goes into where the outfall leaves Hyperion, with that 5-mile outfall leaves. It enters and sometimes it has to be pumped out of the ocean when the tides are in, and sometimes not. It just can go by gravity out.
Okay.
What is the ultimate capacity of the 18-inch line? Do you know, or?
Yes, I believe it's 8.1 MGD.
Okay, so.
All right. And okay, I'll just continue. So please turn to slide 14 of the presentation handout. So just to kind of recap, we just kind of finished the discussion on the Edward C. Little facility, and now I'll be moving on to the 3 satellite facilities. I'm starting off with the Chevron nitrification treatment plant, which was constructed in 1997 and is owned and operated by West Basin. Here below you see a kind of process flow schematic of the treatment plant, which I'll go into a detail now. So the nitrification process has 4 upflow biological aerated filters. And, those are also referred to as biophores that perform nitrification to convert effluent ammonia to nitrite and nitrate. Sodium bisulfite, sodium hydroxide, and carbon dioxide are dosed upstream of the biophores to remove the chlorine residual, add alkalinity, and raise pH to mitigate any kind of nozzle scaling. The treatment plant operates at 1.25 mgd per biophore unit, with double the ammonia concentration, resulting in some ammonia breakthrough in the biofloor effluent. The biofloor effluent is dosed with sodium hypochlorite into a breakpoint reactor to provide just enough contact time to convert any remaining ammonia into chloramines. Then the ammonia-free nitrified water is then pumped to the Chevron refinery cooling towers on their site. So, and then also a portion of the water is dosed with sodium bisulfite and used as a backwash supply, while the backwash waste is discharged back into the Hyperion secondary effluent force main that then enters the Edward C. Little facility. All right, now please turn to slide 15 of the presentation handout. So this particular treatment plant has the capacity to produce up to 4.9 mgd of nitrified water. Now here on the figure on the right shows the kind of historical production flows between 2010 and 2019. Now more recently, the production flows have averaged about 3.9 mgd between 2016 and 2019. Product flows at the treatment plant have exhibited some seasonal variations, with higher demands occurring during the summer months. Any questions?
Yes, is some of that decrease just due to changes in the overall production and demand at Chevron? Or is that just due to limitations of the plant?
I don't want to misstate this, but my understanding is I think we're producing, well, we're not at capacity because there is more ammonia breakthrough, or sorry, ammonia in the effluent that we receive. So we're below the 4.9. I'm not sure if I'm answering your question, Director Alvarez, but
yeah, let me answer that question. So, Chairman Alvarez, a good observation. So the plant's 5 mg, like it indicates here in terms of capacity, or 4.9. And when it was first built back in 95, the ammonia level coming out of Hyperion was 25 parts per million. As you probably are fully aware, due to conservation and all the good things that happen in the conservation realm, today it's 45 parts per million. It's twice as high. Now the biophores have been rehabbed and to address some of that, but the original intent was to have you to have 3 biophores running with 1 in standby. But very shortly after commissioning, it was 4 going full blast. Now they've maintained pretty close to capacity, and with some of the upgrades, I know Suzanne, if you want to add to this, but that's the big change that's happened with all of these biophores and all of the nitrified water. Started off here with 25 parts, and now it's almost twice as high, with essentially the same, with some modifications to the biophores over the years. I don't know specifically if they have a decreased demand for nitrified water for some other reason. I'll leave that to staff to respond to that.
Yeah, and the decrease is basically driven by the Chevron demand. They have perhaps optimized some of their processes on their end and request less water. And due to weather demand, at times they just not needing that extra water. We are meeting their demand, even though we are, those biophores are under design because of the water quality issues. So what we are addressing, how we are addressing that, we end up, because we can't produce at 0 ppm of ammonia they requested, so we have to make it up by adding more chlorine to quench that ammonia. So hydraulically, we are meeting their demand currently. So we just end up having to adjust our process to make sure that the water quality is met.
Okay, so it's just more challenge operationally, but we are meeting the Chevron demand.
We are meeting their demand. We're actually at close to maximum of, the demand right now with our 4 at Chevron nitrified.
If the Chevron plant started increasing their overall production, hopefully not.
They have in the past have approached West Basin to possibly add additional Bio4, but just due to the plant size, we're not able to. There's not enough room for extra Bio4 there. We are looking at adding capacity to the nitrified product tank there that may help to dampen that sometimes additional flow, high demand. So that's what we're looking at right now.
And Director Alvarez, you can see from this graph here, even though the average is 3.9, you can see some of the red dots over there and how close they are to the 5 MGD mark. So certain times of the year, they do go up to that 4.9. Maybe not throughout the year, but that capability is there for them to get it.
Yeah, and I would just add one more thing to that. If you look at all those dips, I can't account for all of them, but all the refineries have what they call their annual turnaround, usually in the winter months, January, February, and flows, the demand for water will drop off for that period, and then it's in preparation for their peak demand season, which is summer. And back to your question, Director Alvarez, I was just thinking about, it's been a long time since I've been in the refinery, but not every cooling tower is hooked up to recycle water. They have cooling tower, it's a 1,000-acre site. So they have one big cooling tower. I don't know if it's still in it. I'm pretty sure it's still there. It's a key cooling tower for them, but it's over on by Rosecrans. It's all the way on the far side. And we had tried many times way back in the day, at least when I was there, to get them to connect. That would add more demand, but they did not want to invest in extending the pipeline for whatever reason. But we can check into that to see if that's still the case. That would have come. But as far as the whole crude oil business of cracking those molecules to make diesel fuel, gas fuel, and jet fuel. Long term, I don't know if there's going to be much expansion in that arena.
We agree. Okay, Orlando, go on.
All right. So now please turn to slide 16 of the presentation handout. So now moving on to the Torrance plant. Construction on the Torrance refinery water recycling plant was completed in 1996 and is operated by West Basin on land that is leased from the Torrance Refinery Company. Here, again, you see a process flow schematic of the treatment plant. Similar to the Chevron nitrification treatment plant, the nitrification process consists of 4 Bio4 units sized at 1.25 mgd per unit. Bio4 effluent consists of Title 22 water blended with MF backwash waste, sodium hypochlorite addition, and a breakpoint reactor converts ammonia into chloramines prior to discharge of nitrified water to the Torrance Refinery cooling towers. Backwash waste is discharged to the LA County Sanitation District sewer system. Now for the MFRO process, MF effluent is pumped to the RO process, followed by decarbonators for distribution as low pressure boiler feed water. And then the RO concentrate is discharged to the Torrance Refinery implant sewer system. All right, now please turn to slide 17 of the presentation handout. So the Torrance plant has the capacity also to produce up to 4.9 mgd of nitrified water. Here on the figure on the right, shows the historical production flows between 2010 and 2019. Production flows have averaged about 2.7 MGD between 2016 and 2019. Any questions here? Go ahead and move on.
So similar questions to Chevron. We pump the Title 22 water over here, and then we denitrify the water. Are we meeting all of their needs, or this is for some of their cooling towers and not all of their cooling towers? What do we know?
We are meeting their needs. I don't know. I think Lorenzo, are you on the meeting? Our Suez
Yes.
operation manager.
Yeah.
Lorenzo, can you clarify a little bit of the demand from the Torrance refining company?
Yeah, the Torrance refinery currently has 6 cooling towers in the whole refinery, and they're all in recycled water. And we are meeting all their demand. They only put recycled water in all the towers. And what you see on this chart, you may see they used to take a lot more water earlier in this decade. They used to have 7 cooling towers. At some point in 2012 or 13, they shut one down. And also they did an optimization project to increase the cycles of the cooling towers. So by increasing the cycles, you automatically reduce the need for makeup water. That's the one that we provide them. So there's a little dip there that started to happen about 2013. Then they had an internal incident in 2015 that took the refinery for the most offline for a year or so. And then when they picked up from that incident, their demand never really went back up to what it was. And they also changed ownership around that time. So they might have done a few different things on the way they run their towers that explain that drop.
Okay.
Thank you.
Thank
Go
you.
ahead. And Lorenzo, of course, used to work at the refinery, so he's very well versed in operations there. Another thing, Director Alvarez, I was just thinking, looking down the road, if we ever get to MBR water from Hyperion, of course, there'll be no ammonia in the water, and these nitrification plants will be rendered unnecessary, but that's in the future.
You beat me to my punch. I was going to wait till the end and say, why don't we revisit the Etsy Little plant? Because we can get rid of a lot of these headaches and probably get rid of these terminal plants if we do this process and do it correctly at the Etsy Little plant, or alternatively at another location with another source of water.
Yeah, or in addition to that, Director Alvarez, if Hyperion ever gets to their MBR project that we're working, the pilot study that we've been working on with them and DWP for the past few years. So, but yeah, all those things were considered and somewhat put on hold, I think, waiting to see what Hyperion would do, but that's a very slow moving process. And to sort of coordinate, if they've, like I said, if all the water coming to Etsy Little plant from Hyperion pump station was through an MBR, there would be zero ammonia, and that would change the complexion of a lot of things we do. We'd pay more for the water, but it might all work out in our favor.
Okay.
All right, keep going.
All right, now just please turn to slide 18 of the presentation handout. So additionally, the Torrance plant also has the capacity to produce up to a 3.2 MGD of low pressure boiler feed water. Here on the figure on the right shows the kind of historic production flows between 2010 and 2019. Production flows have averaged about 2.3 MGD recently between 2016 and 2019. All right, now please turn to slide 19 of the presentation handout. So kind of last but not least here, construction of the JMM Carson Regional Water Recycling Plant was completed in 1999. is owned and operated by West Basin. Below, once again, is a process flow schematic that I'll just hopefully quickly detail here. Similarly, but in this case, the nitrification process has only one 1.25 MGD bioflow unit for producing nitrified water. Bioflow effluent consists of Title 22 water, once again blended with MF backwash waste, sodium hypochlorite addition, and a breakpoint reactor converts ammonia to chloramides prior to discharge. And then the bioflow backwash waste is a discharge to the LA County Sanitation District's sewer system. Additionally, the treatment plant has MF membranes and ultra filtration membranes as a pre-treatment for the RO system. MF and the ultrafiltration filtrate is collected in a common tank and pumped to the RO process, followed by decarbonators for distribution as low pressure boiler feed water. RO concentrate is discharged to the LA County Sanitation District Joint Water Pollution Control Plant. Please turn to slide 20 of the presentation handout.
Can we go back just for a second on the
Sure.
The brine that's produced or the reject from the MFRO? That goes to the LA County Sand District plant, and then out to the outfall, kind of similarly to what we're doing at Hyperion for the brine from the SC Little plant.
Yeah, and Director Alvarez, I think the only difference here, Hyperion, it goes to, staff can correct me if I'm wrong, it goes to the head of the outfall. This one, I think the flow is introduced into the influent of the plant. No.
Okay. They just treat it as regular sewage.
Yeah, I believe so. So I had to double check that part, Kev, but I believe so.
But
we'll double check that, Patrick. I think this one might go to the downstream side of the plant, but we'll double check.
okay, the other question is, because in the flow diagram it shows two discharges to sewer and to the joint water pollution control plant, and I assume that we do that under two separate permits. We're paying them to discharge the brine. They're basically charging us on strength there.
Let me bring in Daniel on this.
Just a question, trying to get a handle on all of these different processes that we have in place.
Yeah, our operations manager, Uzi, will be able to explain the permit.
Sure. Good evening, directors. Yes, the brine line actually goes into the outfall line directly, does not go into the treatment plant. It's not treated. We have a totally separate permit. We do get dilution credit. So based on the flows coming from that wastewater treatment plant, each permit cycle, which is 5 years, we can get some dilution credits. The sewer is for cleaning, for anytime we do chemical cleanings. It's very explicit in NPDES regulation that you cannot send any type of chemicals, the words they use, cleanings, they're very specific. They even state backwash into brine lines. So that's why we have to have the two separate discharge points.
Okay, thank you.
Sure.
Okay, Orlando, you can go.
All right, thank you. So please turn to slide 20 of the presentation handout. So here I just want to make one clarification. Sorry, there's a typo here on the capacity to produce a nitrified water. It should actually be a 1.1 MGD, not the 1.25 that you see here. So just wanted to mention that. Once again, here on the right, we show the historical production flows between 2010 and 2019. Production flows here have averaged about 1 MGD between 2016 and 2019. All right. Now, please turn to slide 21 of the presentation handout.
Orlando, if I may, just on the nitrified, so the main difference with this nitrified and the other two that is in Chevron nitrification plant and Torrance is that we produce way more nitrified water for those two. They have 4 units for Chevron, 4 units for Torrance. This one only has 1 unit. The reason for that being is that they take some of the water from the boiler feed, mix it up with they have a little bit different setup for Marathon, the water that comes in from the Carson plant. They use a little bit of the MFR water, blend it with this nitrified, and use some of it in the cooling tower application.
Okay, thank you.
All right, now on to slide 21 of the presentation handout. So here, once again, the Carson plant also has the capacity to produce up to 5 mgd of low pressure boiler feed water. Once again, the figure on the right here shows the historical production flows between 2010 and 2019, where production flows have averaged about 3.5 mgd between 2016 and 2019. All right. Please turn to slide 22 of the presentation handout. So lastly, the Carson plant incorporates 3 distinct pipelines for conveying different flows to different locations. The brine line is a 14-inch outside diameter HCP pipeline, approximately 5.38 miles in length, en route to the Joint Water Pollution Control Plant. I guess their outfall, as Uzi just mentioned. The low pressure boiler feed ductile iron pipeline to the Marathon refinery ranges between 30 inches and 24 inches in diameter in different segments, and it's approximately about 1.13 miles in length. And the nitrified water ductile iron pipeline to the Marathon refinery as well is 12 inches in diameter and approximately 1.17 miles in length. And here, just kind of let's talk about some of the figures that you see on the right. At the very top is the brine line alignment, starting at our Carson plant, and then basically traveling in a kind of southwest direction to the joint control plant here. Then here in the middle, you see the low pressure boiler feed pipeline, once again starting at our Carson plant, traveling south along Wilmington Avenue, reaching the Marathon refinery. And then here on the bottom figure is the nitrified water pipeline. Similar to the low pressure boiler feed pipeline, just travels south along Wilmington Avenue until it reaches the Marathon refinery. All right, just please turn to slide 23 of the presentation handout. So as you can see, from all the previous slides and discussion points, the master plan analyzed and evaluated a lot of data from West Basin's recycled water treatment facilities, from the treatment processes to the existing capacities, historical flows, and much more. This data was a key in identifying some rehabilitation and replacement projects for the near and long term, as well as some recommended process optimizations that can help improve operations. Now, if interested, examples of these projects can be found in the capital improvement program, which is chapter 9 of the master plan, along with some of the recommended timelines for when to actually perform these projects. And here I'd just like to kind of quickly discuss the figures just to recap. This is an aerial of the Edward C. Little water recycling facility. Here in the bottom left is the aerial of the Chevron nitrification treatment plant. Just to the right of that, it's the aerial of the Torrance refinery water recycling plant. And then to the far right is an area of the JMM Carson Regional Water Recycling Plant.
Orlando, on the Chevron plant, where is that? Just what's the intersection?
This is it's actually showed the north direction is actually to the right here. So this here is Illinois Avenue in El Segundo, and then this is El Segundo Boulevard. So this would be the north west corner of that intersection. I think it's a T intersection. Further south is the actual Chevron refinery on the other side of El Segundo Boulevard.
It's close to El Segundo Boulevard and Sepulveda, just a little bit, a couple hundred yards down from the intersection.
Yeah.
Okay. Just wondering, I never quite knew, I always said, where is that plant?
It's well landscaped and concealed.
Yeah.
It's right directly across, as Orlando just mentioned, directly across from the refinery.
Yeah. All right. And that is it. So I don't know if Director Alvarez or any other committee
No,
members.
covered a lot of territory, and there's a lot of good information to try to get a handle on what we've got, what our limitations are. And I think we're going to be, at least I will have follow-up questions and probably want to revisit some of these things in more detail. But to the comment that the general manager made earlier about really looking at the MBR process and installing that at the plant. As we go forward, we really ought to do as much as we can to go 100% recycled water for indirect portable reuse. And ultimately, you're going to hear me really push for direct portable reuse. So we need to make that investment and be more focused into how we do that. Right now, we're making a lot of investments, not only at one centralized plant, but at these terminal plants. They add a lot of O&M costs. They're on land that we don't necessarily own, that we lease. So there's a lot of issues with that. And a lot of that could be short-circuited if we could produce all of this water at one or two centralized locations. That's an easy statement to make. There's a lot of that goes into that statement, including making sure that we have the water source, the raw water source procured on a long-term basis, and what that amount of water requirement is. And as we look at the recycled water master plan, I think we ought to think about doing a little bit more work in tweaking that master plan to address that. Some of those questions that I'm raising and concerns that I'm raising are covered in there, but they're not really tied together in directive form. So with that general comment, it's already 7 o'clock, and I know that Director Houston said that he needed to go, so we'll wrap this up. Director Houston, do you have any comments?
Yeah, I just want to say a couple really brief things. One is I really want to thank staff for this extremely thorough presentation. I remember when I was just first flipping through it, I saw how many pages it was. So I do want to commend you. It's a lot to take in. It's unfortunate that we are not all here to listen to that for various reasons. And so I think this, at some point, we're going to have a specific conversation, as Director Alvarez mentioned, that's just solely about this in a, in a much, how do I say it, like a tighter context, or a context where the board members can really get into the weeds a bit, but yet it's got to be a, high enough level, sometimes the staff can talk individually directors on some of the nuances, but all that being said, I completely hear where Director Alvarez and those questions were going, and some of the things he was talking about and capacity issues. I think that those are very valid questions, and I think that we need to look at that. And also, I believe we should take a step back and reevaluate what the priorities are for the district. Because yes, I think there's been a lot of things done a certain trajectory over many years, and we're at a point now, especially with aging infrastructure, where we're rethinking that. Just like you see also the cost of building all these lines and how much it costs to produce water to these certain locations. So anyway, what I would like to see, and I think President Williams, I'm hoping he's probably there, is that we have that type of workshop. I've been asking for this for almost 2 years now, to really understand what is happening with all of our neighbors, so this district can be a player, but also have a plan for what our future is. So anyway, this continues to keep that dialogue going, and I want to really look at the options we have at the Ed Z Little Water Recycling Facility. And with that, no, I have just a few minutes, Chair Alvarez. So, but by the way, normally if I didn't have to go, I would not be rushing either, because I find these meetings very important and informational, staff. So just please know that. So thank you.
Thank you. Okay, so let's kind of wrap up the meeting. On the other information items on the information calendar, the other items, we'll skip them. We have the background material, and I think we can just go over that background material. If anybody has any questions, they can bring them to the staff for answers. There's no closed session, so the last item is director comments and future agenda items. Director Houston, do you have any comments?
I basically gave them all for the most part, although I would just still say again, thank you, staff. I know it was a long meeting, it was a good meeting, and yes, I have already perused most of this, and we'll go back and look at some of the other things we didn't get to talk about. So I just want to assure you, I really always thoroughly read my packets. I look through them. So just understand, I think you all known that for years with me, but I learn something new all the time. And so today was really good getting in the weeds. So I want to say thank you. The only other thing was, the ad hoc committees. I know that we're moving forward, and I'm not sure how those get reported out. I think Director Alvarez may look at that, but I just want to mention that we have been starting to move forward, at least with one of the ad hocs, and I think that that's a very good step. So with that, thank you, Mr. Chair.
All right, thank you, Director Houston. So just a couple of comments on that. First, with respect to the ad hoc committees, we do have the Brewer DeSalter ad hoc committee. That committee's met twice and we'll be meeting again. It's moving forward. It's got an agenda. We're working with the general manager on trying to expedite that process. We've set a timeline of trying to get through that in 180 days. That's maybe a little bit aggressive, but at least it sets a timeline. There's also another ad hoc committee dealing with the city of Los Angeles, and we have multiple agreements with the city of Los Angeles. That is something that the general manager and the ad hoc committees are working on, and we'll be scheduling some meetings shortly. And then the last ad hoc committee is the ad hoc committee on the ocean desalination project, and the members of that committee are President Williams and Director Deere, and they're not here to give a report, so we'll skip that. In terms of future agenda items, I think we need to, because these meetings can be very long. This is the second meeting now where we've gone for more than a couple of hours. And the idea was to try to keep these meetings shorter. So we need to really try to make the agenda a little more concise. Probably want to come back and revisit some of the treatment facilities issues that we've identified in terms of as we move forward, how should we focus till we have a better idea of improving the amount of water that we're producing for indirect portable reuse, and how we can do that in a more efficient fashion. So it's both not only improve the efficiency of the system, but improve the overall capacity of the system and where our shortfalls are right now. And along those lines, I'd also probably want to add a discussion of our distribution system and where we're headed with the distribution system. Is that consistent with a long-term commitment to indirect and then direct portable reuse? So with that, I think staff, you have any comments or questions or any additions?
No, it was a great meeting and a wonderful presentation, last one especially there by Orlando at home with his young baby, and great input from the board, and a lot, some of this will, in terms of the bigger picture discussion on what next for West Basin and looking more long-term, that will be part of the soon-to-be conducted retreat. That'll be a big part of it. So we'll be there very shortly on the 15th, May 15th. That's all I have. But thank you, directors, very much, and thank you, staff, and thank you, Craig, for hanging in there, and thank you, HDR folks, for joining the meeting today.
Thank you, Patrick. Good meeting.
All right,
Yes.
well, thank you all. And with that, we're adjourned.